So have fun. So. Awesome.
No problem. Duran, right?
Doran, yeah, there should be 2 for Doran. I have Davis as my student. Do you want me to take the ones that are my students?
And then I'll have you sign them all. So there's that.
I have Davis, Miller, Doran, and Cross.
Doran is right there, it looks like.
There should be 2.
2 Dorans.
Yeah.
Yep. There we go. Cool.
Okay. See, so on here it says assistant
Wow.
using Doran.
Okay. How close are we to being all signed in here?
I mean, we have 1, 2.
Yeah, right? God. Okay.
Hi, how are you?
Check the, check with Amanda. It doesn't? Jesse, check in Amanda's office in the travel cases.
Yeah, I'm gonna unplug you guys for just a moment. I'm gonna unplug that whole row for just a second. So beware. So these are all
Yeah, there's 2 reasons. All right, you know. So yeah, so he was We don't have any more room, Jeff.
Are you serious?
Should we figure the classroom?
People are like bringing extra people. It was like bring one.
Okay.
My God. Yep.
Everybody in here have hardware so far? Anybody?
Go, 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 go.
I checked it. I brought it. It'd be nice to use your own, but
We can start with one line.
I don't know if this has the RedBot.
I don't know do you know the netbooks? Netbooks do either? The last name's Shinsky. Initial for me. Sign on the dotted line. You're not signing your life off. Matt, right? Perfect. Can you initial right there? Here, and that means you get hardware, which is okay. Thank you, Matt.
Okay. We're close to
we're ready to go.
Live?
Yes.
Okay. Point of order is we're streaming this class on the internet right now, so if you're in the witness protection program or there's some other mitigating factors, let us know and we'll position you strategically so that your enemies don't see you. I'm Jeff Branson. I'm with the Department of Education here at SparkFun. Welcome to Intro to Robotics with the RedBot. So, did you have administrivia?
Just introduce myself. I'm Brian Long, the education engineer here, former high school teacher, and I'm only going to be here momentarily. I got a robotics team, down in Aurora that is building today, so just here to help.
So Brian has a long history with First Robotics, and his teams have gladly and happily finished very well nationally, and we wish you luck this year. So.
I'm Eric Rubber. I also work in the Department of Education, and I'm the curriculum specialist in the curriculum area here at SparkFun. We actually write curriculum for as well as libraries and whoever else wants to learn music. So that's my job.
We have Angela, who is our e-textile specialist in the back. She is auditing the class today, but is also a wonderful resource if you have questions. And a round of applause for our videographer, Mike, in the back. Right? So Mike is actually a rocket scientist, but we use him for video. So, okay. So there's a broad range of abilities in the room. This class assumes that you've never opened Arduino before. For those of you who have, bear with us. We're trying to get everybody to the same level at the same time. Is there anyone in the room who has not used Arduino before? Okay, is there anybody who doesn't have it installed on their machine? Everybody? We like 1.5.0. 1.05, sorry. You're fine either way, but the libraries are kind of a little sketchy with the 2.0 versions. Perfect, you're fine, you're good, you're good. So we do a lot of robots here. This class is the beginning of a ramp that we hope ends with you joining us for the annual autonomous vehicle competition. This is probably the most spectacular spectacle that SparkFun does every year. It is teams from all around the world, ground vehicles and aerial vehicles, both fixed wing and rotary wing, racing around predetermined courses at the Boulder Reservoir, and it is super, super fun. So we hope that today leads you to that place. Derek, do you want to talk about SparkBox really quick?
So we're trying out a new tool today, and this is actually the first time we've tried it on this many people. It's called SparkBox. And basically, it's actually this little white box up here on the whiteboard. It's broadcasting actually a wireless network, and it hosts its own website. So if you if you look at your wireless networks, you'll see when it says SparkBox. If you join that network, it has all of our instructional materials for this class as well as other classes on it. So that's actually not connected to the internet at all, but it's so that, for example, like the basic, which Arduino do I download or use? The one that we usually use is on there. The RedBot library is on there.
So I want to go to that URL.
So it's actually, once you connect to that wireless, it should automatically take you to that URL. It takes a little bit of time. You're going to have to hit your URL box type, SparkFun or SparkBox/content.
Yeah, got it. Sweet, thanks.
Good.
So this is going to be, if we all get on the wireless, just the regular wireless at once, it will slow to a crawl. So this is our attempt to try to get a lot of material to you guys really fast. Because there's no TCP, there's no security calls, all that stuff is stripped out of SparkBox. It's just our way of dumping content to you guys really fast. So if you're interested in SparkBox, actually, really quick, this is an outgrowth of a project called LibraryBox, and it's open source and free to build one. Super cool stuff. We're indebted to Jason Griffey for his work on LibraryBox and helping us port it to our my cover slide, and I think everybody's pretty well situated here. As a brief overview, Mr. Ellett? All right, welcome. So I think, Derek, you've got everybody checked in?
Yes.
Everybody's on the boat. We're leaving. We've done some introductions really cursorily about people in the room, with the exception of our friend Matt and his friend Rosie. This is Rosie.
Matt.
That's Matt. So Matt is one of our production technicians and has taught with us all over the country, so he'll be joining us today.
I was walking through the classroom yesterday, and Jeff said, "Hey, you want to come in tomorrow, don't you?" And I said,
"Okay." So this is a brief overview of the day. We'll go through and talk about some of the particulars of Arduino and RedBot. We'll install Arduino, the libraries, and get the board up and running on each and every one of your computers. We're going to move from kind of doing some simple programming work here to doing some hands-on build of the chassis and getting ready to run stuff. We'll start with driving in a straight line, using pulse width modulation, PWM, to go both slow and fast. We'll cover the functions in the libraries written for the Red board. And then we'll actually start doing more in-depth control over that stuff. After lunch, we are looking to move to the robot tables that are set up around the room to get your robots line following and maze navigating. After that, we'll add another sensor, the sharp infrared sensor. We'll add a servo to that so that it can look around the room and see what it's doing. And then what we want to do is, we've talked about adding XB to this. I want to see how the flow of this class goes. This set of stuff right here between kind of 2, 3, 5 is an open swim area where we have not run this class with a varied group like this before. We want to give you guys time to experiment with the platform in the presence of people who can answer questions. We want to give you time to do open-ended projects. We can introduce additional topics as you request. So this class is designed to let you pursue personal interest at the end, and we will be here to answer questions and deliver additional content, but we also realize that 6 hours of robots can be an awful lot. So if you're full, you're welcome to, go be outside on a nice day or do whatever you need to do. Really quick. It helps us a lot to understand who we're teaching to if we can have a couple of sentences about you and who you are and what you expect from us. Leah, you're an old hand. Could you start?
Hi, I'm Leah. I'm an artist. I'm teaching art classes at University of Denver and trying to integrate this technology into this cultural art.
Excellent. Welcome.
Joel, I'm Gabriel and Grace.
Awesome. We love family robotics. Yes, you are.
I'm John Miller, and this is my first robotics class.
I'm Robert Davis, this senior, teacher of electrical engineering student.
I'm Gloria Ryan, and I'm a robot.
I'm Jack Rydell. I'm a rocket scientist by day, and my daughter Martha. We're here to build the robots.
I'm Susan. I'm a
I'm Steve. This is my son Sasha. This is here to learn a little bit about robotics.
I'm Sasha, this is my dad, and I'm here to learn a little bit about robotics.
I'm Sam. I'm a high school student. I'm just here to get a little advantage in the autonomous vehicle competition.
I'm Jill Cross, and these are all my students.
Where are you? What school are you?
Collegiate Academy, K-12 charter school in Littleton.
Okay, very good, very good. Okay. Awesome. Oh. So you'll hear a lot of talk of Arduino today. What is Arduino? Arduino is hardware and software. It's open source. The software for programming is free. It was developed by this kind of criminal-looking group of men at the Ivrea Institute in Italy in 2005, 2006. It is an outgrowth of the processing language. Is anybody using processing? So, Leah, we know you are, but processing is a free open source language for programming. It's designed for artists and designers, and it is really, really easy to use, really easy to get into. Do you want to add anything on pros? Okay, all right. Derek is processing ninja. There is a cult of processing that exists within this room. I believe Angela is a member of that cult. So Angela, if you would show the pineapple later, I would be so thrilled. Awesome, awesome. So Angela is like doing e-textile stuff that borders on robotics. And so there's a lot of stuff that comes out of processing that's really useful to kind of building interactive environments around robots and interactivity. So also, Arduino has some derivatives, RGBlock, MiniBlock. There are a number of graphical programming environments that go with Arduino. So the ability to kind of take a student or a young person from something like Scratch into Arduino is now expanded on by these graphical programming environments. So if you have a particular interest in that today, we can point you in that direction during Open Swim. Arduino is named after a bar in Italy that these guys all used to retire to after a hard day of programming. Arduin was actually a king of a province in Italy around 1000 AD, and it actually means strong friend. So they named it after the bar they all went to. And we like Arduino 1.0.5. The later versions sometimes have some instability with libraries. We stick to the tried and true tested versions. There are a lot of variants on the hardware that goes with the Arduino software. So there are the e-textile stuff. And Angela, can you talk a little bit about the e-textiles variants?
Big example of the Arduino that's sewable. So this little hole is actually stuck to thread and something. So we're using wires. We can also sew things, and that's my specialty. There's a bunch of sensors, so anything you can do with Arduino, you can do with a wearable Arduino as well.
It comes with built-in wireless ports. It comes in very small form factors. It now programs probably about 35 or 40 variants of hardware. And ranging from very inexpensive to build your own Arduino is a few dollars, all the way up to stuff like the Galileo, which I think is about $80 or $90 and is a full operating system. It's an Intel Quark processor that is programmed through an Arduino environment, but also has a Python kind of operating system or pardon me, a Linux operating system running side by side with Arduino. So there's a lot of work that can be done with this. Arduino has kind of taken the maker community by storm. So if you're familiar with Make Magazine, Maker Fairs, all that stuff, a tremendous amount of the projects, maybe half the projects that we see coming out of the Make culture are centered on Arduino. Questions? Okay. Who's programmed with Arduino? Okay. How many people have run Blink? Almost, okay, about half the room. Okay. So what we're going to do today is we're going to use the Arduino software and a library, and we're going to go through getting that library. Has everybody been able to log on to SparkBox? You haven't. That would be advisable. The other way to go about this, if you're on the web, you can log on to the SparkFun wireless, and you can grab the library as a download from the product page for the RedBot. So if for some reason you're having problem with SparkBox, I can go to sparkfun.com. I'm going to click on the Shop tab. I'll look for RedBot. In the Search tab, when I go to the RedBot kit, down at the bottom underneath the video and underneath the hardware stuff, it says Arduino library right here. And if I click on that, it'll automatically download. So we're going to need that library on your computer to do today's examples. So one way or another, it's either on SparkBox or you can pull it from the web. Everybody's going to need to get that library. So if you go to the, are you on one of our computers or is that yours? Okay, if you look on your wireless, you should see a wireless connection that's called SparkBox. Okay, so
Google, open up a. So then just go to try typing in Google, and then you should do a redirect.
Derek, if you can't get it up in a standard browser, just put in SparkBox.
SparkBox/content.
SparkBox/content. /, yeah.
Any idea why?
Page not available. Did you?
Yeah, that's how I did it.
You got it. You got SparkBox then? Can I see? Okay. /content.
Try sometimes you try rebooting and see. You tried that. Sometimes the settings. It doesn't look like it's detecting your wireless.
It's not.
If it doesn't automatically correspond.
Get a list and get the SparkBox.
Oh.
It's XP.
Yeah.
I mean, it should still work on XP also.
Up, second /.
But you're on a regular wireless.
Drive?
Just change the C to an X. And then //. Here we go. Oh, no. Can I want to try one more minute.
Okay. Is there anybody who's having trouble getting the library into downloads?
Once we're there, are we caught up?
Yes. Yep. And-
Just. Is this?
168. No.
Yeah,
have the IP address?
It didn't work. I mean, this is fails.
Yeah. So,
IT guys in the room will appreciate this. For whatever reason, anybody can go help us figure out why it's not configured right. If you're not able to see SparkFun, when you open up a browser, it just says, broken or whatever. You can also just type in the IP address for the device. It's 192.168.1.1, which is standard gateway for.
any problems? Can we go? Speak now or forever hold your peace. No. Leslie, you're shaking your head no. Okay. What do we got? Okay. Oh.
So you can also check in that'll definitely get you 192.168.
So Leslie, you're having problems.
No, I'm just
That's like the, I mean,
Okay.
people don't like
Okay.
four numbers.
Okay.
At some point,
And
do more.
Kelly, is that right?
Those numbers are part of
Did you try the 192.168.1.1?
What do you think of it? There's a lot of it.
Okay. Anybody else having problems? Okay. If you have this, you can, I'm counting on the fact that everyone has Arduino installed on their machines. So if you have Arduino installed, you're going to unzip the library to the Arduino folder and the libraries folder inside that. So if you go to your documents and open up your documents, you should see a folder called Arduino. When you open that Arduino folder, you should see a document called libraries. We're going to unzip that RedBot library into libraries. Yes, sir.
What is unzipping?
So if you, are you Windows? Yeah. So you have a download. If you click on that download, it should open up, and on the upper left-hand corner, it'll say extract to. When you click that, you're going to point it to this file path. Documents, Arduino, libraries.
I got a quick question. So I just want the RedBot folder and all that junk in my libraries in the Arduino programming environment.
Yes.
Okay, great.
Anybody else? So if you're not sure about your library's location, when Arduino's open, you can find it under the File tab in Arduino and Preferences. It'll tell you in there. And I'll model this for everyone.
Don't include USB cables.
Get them from Amanda's office. Okay, so as a matter of kind of visual, this is my documents library, and Arduino is right here. It makes no difference if I'm running Windows or Mac. When I open that Arduino folder, and I'd love it if everybody did this with me so we could verify that those files are in place. So when I open this, actually over here, I should have a folder called Libraries. And my libraries folder is up here. When I open libraries, you can see I have a bunch of folders, and one of them says RedBot. So far, so good. Matt, yeah, thanks. Are you?
I'm gonna take off afterwards.
Thanks, Brian.
This is great.
So, I just want to make sure that everybody has a folder called RedBot in the documents library. Does anybody not have a folder called RedBots in the document library? Yes, sir.
Would you suggest putting making a file in main RedBot and put everything but readme in it? Like I just did that.
Arduino, libraries. That's good.
Okay. Is readme supposed to be in there, or?
README is just a description. That's a human page for you that talks about what that thing is. So you don't need to worry about it. You're good. So, okay. You need me there? Yeah, got it. Hey, Matt, will you get with Leslie and make sure that stuff installs for her?
I'm grabbing it.
Okay. Yes, sir. Okay. So did you do the download? Okay.
You want to use the loop pad one or do you want the black one? It's awesome, but it's so short. I have 2 kids.
I'm going to get you a mouse because that keypad is really, oh, you got one, okay. Okay, so you're going to need to download Arduino, the Arduino software. You're going to go to arduino.cc.
Okay. Do I need to get on a network?
Yeah, and it's SparkFun. The network you're going to get on is called SparkFun.
Yeah, I did do it. I'll show you. Thank you.
Hey, Derek. Are you going to use just this, or are you going to use both of these? Okay. Can we walk them through the library on this?
Yeah.
Are you good?
Walk them through, yeah. I just have to remind me the internal order and go get more
Cables.
cables before Amanda flips.
Right. Don't even say anything. So, okay. So I'm assuming everybody's relatively close to or has the library kind of put in its place. This is the worst part of this whole thing, is getting stuff kind of together. I'm going to talk briefly about the RedBot mainboard, and you're welcome to take that out of your box and unwrap it and kind of play with it. You can touch it. Don't put your tongue on it or anything else like that, right? Well, I mean, you could, but like that, it's weird. So this is a version of the Arduino, and it uses a specific hardware version called the Arduino Uno. So half the fun for me is always opening new hardware, so I'm giving everybody a chance to like take it out and get familiar with it, friendly with it. This is both the brain and the legs of your robot. Well, more technically, the the legs would be the platform. But on this chip, running 5-volt logic and powered by 6-volt stuff is a driver. So that driver actually provides high power for robots. So all of the computational stuff that we do, the thinking part of robotics, is done at a TTL level, a transistor to transistor logic level, 5 volts. So what the driver does is it translates that low voltage, low current level that happens at the computer into high voltage, high current stuff that will drive motors, solenoids, actuators. Am I missing anything?
You're good.
Okay. So we have a USB programmable chip on here. So when we plug that USB cord in right here, this chip takes what comes across USB and it translates it into serial that this chip understands. Most computers speak a form of binary called serial, which means that we send ones and zeros, one after the other, through the system. USB does not. USB is designed to do file transfer very, very quickly. So it takes whole chunks of information, photographs, music, video, and it breaks them down into bytes and it shoves them through in a parallel stream. So I have 2 streams of data going through one way, or I have 2 streams of data coming back the other way. What this chip does is it reassembles or takes apart the data that we're transferring across this USB port. There's an XB footer on here. So this XB footer accepts a standard XB style radio module. And those radio modules come in a ton of configurations. They come in 900 megahertz. They come in 2.4 gigahertz. They come in Wi-Fi and Bluetooth. So we can use that footprint to talk to this robot through all kinds of different radio frequency stuff. And if we get time this afternoon and there's interest, we're going to try to plug some XBs into this stuff. So there are 2 motor ports on here for connecting motors. Those motors are going to run on 6 to 9 volts. There are servo headers on here so we can connect servos. And if you're not familiar with servos, they're smart motors that go to a specific position depending on a signal that we send them. So I send them a pulse width, basically a square wave of power, and they go to a position depending on the width of that pulse. We'll talk more about that later. So there's also a bunch of header breakouts on here that will take sensors, and we'll be using those really quickly in this class. If you look at the screening on the board, and I have a better slide for this, we can talk about the screening. The screening labels a lot of the functionality of the board. So on this side, I have my headers that are for the analog and digital inputs. And this one is calling out A4 and A5, so we're breaking out the analog pins to A4 and A5. All of our sensor headers, all of our servo headers on here are broken out to the pin on the chip that they're talking to. So I'm taking information from this chip or reading information to this chip on one of these legs. And when I talk about which one of these legs it is, it's actually one of these numbers. It's A4, it's A5, it's pin 10, it's pin 11, and that all corresponds to what's happening on the chip. The nice thing about these RedBot boards is that they take this, what is this, Matt, TQFL package, right? What's this pitch on this? It takes this tiny little pitch and it breaks it out to pins that we can actually get to with our fingers and with wires. So, and that's kind of what SparkFun does, is we take these chips and put them into human manageable form. We write example code. The XB switch on here is going to be really important to you at some point in time if you're using this. There are two forms of XB. One which reads the standard pins on the chip that talk through the USB port, and the other one which reads pins that aren't connected to the USB port. If this is set on XB HW, which is XB hardware serial, and there's an XB plugged in, it interferes with the USB signal. So we are able to switch between that hardware signal where we can read stuff on the USB hub, or we can switch to a software signal which selects pins on the chip to talk to. So that's it's a little farther down the line. We have a power indicator that says, hey, the board's turned on. We have great switches on here that break out turning off and on the motors, so we can download code and play around and turn the motors off and on without unplugging and plugging stuff in and having the robot take off and roll off the table. Has this happened ever?
So I play with my 4-year-old in robots. I do the programming and he gets to kind of tell me what to do. And he strategically hit a button at the wrong time when it was on the kitchen counter, and my robot ended up breaking into lots and lots of pieces. So that switch is very handy when you're working at a tabletop that's high level, hardcore. You know, want to make sure we're being very mindful of our robots running off the table.
So the settings that we want right now in these three switches are, we want to make sure that this switch is set to XB software serial, motor is set to stop, and power is set to on. So once again, software serial, we're going to select software serial, we're going to select motor stop, we're going to select power switch on, and we're going to plug those into our computer. Ooh, I'm hearing boink.
Wait, do we put motor to stop?
Put motor to stop. How many Mac users do I have? So this is a question, this is a thing for Mac users only. Mac users, have you run Blink on a board before? Who has run Blink? Who has? What I'm concerned with is if you're a Mac user, there's an extra driver that we need to install. If you haven't used an Arduino board before, you won't get a COM port, and we need to make sure that driver gets installed. So if you're a Mac user, you have not used it before. Okay, so what I need you to do is get on our wireless network, on the SparkFun wireless network, and you're signed in. So you're going to go to ftdichip.com, and Matt, would you walk her through the DMG on that? Thank you very much. Any other Mac users who may have a question about those drivers? Matt's running around. He's really good with the Mac operating system. Windows. Let's open Arduino and get programming. I'm going to plug a board into my computer. Do we have any questions from the internet? Do we have people on? How are we doing?
We're doing fine. No questions.
Yes. Well, I'm plugged in right now. So I'm plugged into the board and I'm plugged into the USB pin. And the first thing I want to make sure of is I have a green light. So far, so good. I have my green light. The next thing I'm going to do is I'm going to go to Tools. I'm going to select Arduino Uno from the Board tab in Tools. So I have all these options of hardware that I can program with Arduino. I'm going to click on Uno, and I should either get a check mark or a button next to it when it's selected. One sec here. So the next thing I'm going to do is I'm going to go down to serial port and
Under tools?
yep, so I'm going to go to Tools, serial port. So when I go to Tools, I should get a serial port. I'm on Windows 7. My serial port here is COM91.
If it's grayed out.
You don't have a port?
Yeah.
Okay, so is your board plugged? Okay. So hang on just a second. How many people have serial port here grayed out? It's not shown in black. Okay. All right, so here we go. You guys watch this carefully and follow along. I'm going to go to the Start tab. I'm going to go to Control Panel. So I've opened up Control Panel. Under Control Panel, I'm going to open System. And in System, I'm going to click on the Device Manager tab. So far, so good. Is everybody at Device Manager? System, or yeah, hardware. So Control Panel, System, Device Manager. So when I open the Device Manager, and this in Windows, this is a standard install for most of the embedded systems hardware out there. This is pointing to a driver, so it's a great skill to have. I'm going to go to Ports. Under Ports, I have a USB serial port that enumerates and has a COM number, COM91. It means this is the 91st piece of hardware I've plugged into this computer. Make sure the board's turned on. It's okay. Double check the switch settings on it. Unplug it and replug it in and see if it comes back up on the port. So So you're gonna, so some of you will see FT232R, USB UART, and I'm gonna right click that and click on the Properties tab. So yes sir?
So if it's gray but we have nothing plugged in, nothing's wrong?
If it's gray and you have nothing plugged in, then nothing's wrong, you're okay. If you plug something in and it shows up, you have a number. Your number's probably 4. Okay. Is it 4?
My dad says yes.
Okay, then you're golden. So the next thing I'm going to do is if I have something that has an exclamation point in a triangle next to it, I'm going to right click. I'm going to click Properties. I'm going to click driver, and I'm going to click update driver. Matt, how we doing? All right, so we'll do him individually.
Do we search for one? Search automatically. We have search automatically and browse.
Browse my computer. So the next thing you're going to do is hit browse my computer. So far, so good. And you're going to point it towards Arduino that's in the program files. Wherever you downloaded Arduino, like we always download it to program files. Not the one in your documents, but the actual Arduino EXE that lives on your desktop and your program files, wherever you downloaded it to. You're going to point it at that. When you open Arduino, you should see a folder called drivers. So I'm going to break from Windows for just a minute. When you click that drivers folder, Windows people, you can click continue and just go through the scripts. You'll do it twice. You're going to need to do this install twice for Windows 7 and above. It does it once for the USB hub, and it does it once for the driver folders. Mac users, when you click on this, when we click on Tools, Mac users, under serial port, when I enumerate here, it should say / dev TTY USB. Are we seeing something like that for Mac users COM port? TTY USB, and then it has a hex address.
A602.
Yeah, it'll be some random.
It'll be a hex address. It'll just say / dev TTY USB serial and a hex address.
Do TTY instead of CU?
Yeah, do TTY. Yep. Occasionally, very occasionally, depending on the packages, the development packages you have installed, you will have to use CU, but that's for you guys only, because I figure you guys are probably doing some kind of development packages on it. If it doesn't recognize on a TTL, go to the CU. Very occasionally, if you're running Eclipse or some of the Java stuff, it enumerates through CU. So. So far, so good? Okay. Okay, hey, Derek, these guys aren't enumerating, and hang on, let me see what we got here. Can I squeeze through here? Okay, so is it still in downloads?
Maybe.
It's in documents.
The whole thing's in documents?
Yeah.
Okay.
It's the 1.05.
Okay. So drivers right there. That's the one. You want to point it at that and click OK.
Okay.
Okay.
We're going through the second driver now, so.
Okay, so it did come up. Okay, good. 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 We're almost to the point where we can teach this robot its first lesson. So we're almost there. We're through the hard part. This is the worst part of it. How many people have not been able to get a COM port up? Everybody's got a COM port up except these two gentlemen here. Is that right? We're good? We're good? We can go? Okay. The next thing I'm going to do is I'm going to go, and I'm going to have everybody do this with me in Arduino. Everybody's doing this. We're going to go File, Examples, Basics, Blink. And gentlemen, if you get too far ahead on that robot, you'll have to take it apart, so I would caution you. So I now have a SketchUp called Blink. Is everybody got Blink? Does anybody not have Blink? Help. Right? Okay. I've got blank. Going back and and repeating, we've selected Arduino Uno. I've got a serial port, and I need to make sure that I either have a dot or a check mark next to the serial port. So when I enumerate my serial port, whether it's a COM port or it's a TTY USB port, I want to make sure there's a check mark next to it. When I load code to the Arduino, our designer on this board, Mike Horde, who's a genius, put two little lights right next to the serial port. These are the RX and TX lights. They're receive and transmit. So as data's going back and forth between this little computer and my big computer, I actually have a light that flickers that tells me that I'm getting transfer on that data. So when I click upload, I get a script in Arduino at the bottom. I get a script in Arduino at the bottom that says compiling sketch. There's a little status bar right here. And then finally, come on. Where's my code? It says done uploading. I'm not getting any blink on this. Why am I not? Is there not an LED on? There's my LED, but I'm not getting any blink on this. It's loading code. I know it is. I wonder if that light's burned. When we load that code, we should get a blink on the board.
Upload again. Did the RX and TX lights go blinky blink?
No. No, and there's my, hang on. It says done uploading, but it's not uploading. Shit. Of course, in front of everybody, right? Hang on. So when this works, we should see a light, a user LED blinking right here. Is that happening for anyone? The code loaded? Are we blinking? If you're blinking, you have just loaded your first code to the RedBot main board. So who is not blinking? Okay. Try this.
Where you got the wheels? I know you're like, I gotta open the wheels. I gotta. Oh yeah.
Okay. Okay, something just... Okay, so is everybody at the point where this light right here is blinking? We're blinking? So I heard a no. Okay, so make sure that Uno is selected. Make sure that the COM port is selected. Make sure that the power switch is on.
Yeah, that's all running right.
45 seconds of work route. It's like driving around. It's gonna like stop as you're going backwards.
Okay.
I don't think your drivers are on there. I want the control panel here. System.
Yeah, or yes, doesn't matter really.
All right, device manager. Yep, your driver's not installed.
Okay. So it saw it, but it...
It's, oh, you're seeing the hub, the USB hub. You should be seeing 2 ports.
It automatically.
Where is Arduino? Is it under program files?
It's whatever the default. I didn't change any of the defaults when I ran it.
So when you downloaded it, where did you download it to? Is it in program files? It's not there. There it is. So I'm going to hit drivers. I'm going to hit OK. I'm going to hit next.
From the website. Okay. Yeah, so where are those now?
Okay, unplug that and replug it in.
You don't need the driver? Yeah. You did that at the library.
Really?
Where is Derek? This window 8 error.
Yeah, this is a new computer that I'm not...
Hey, Derek. Derek, I got a Windows 8 I got a weird Windows 8 hash file problem. I think the download, will you look at this and see what you think? I'm pointing it at the driver's file in 8 and it's not, like it won't. So really quickly, while we're getting everybody blinking, I want to give you guys the opportunity to go in and play with this code. We've declared an LED pin, and here it's set as 13 up above. If I scroll through that, you can see that it's declared as LED equals 13, which means that pin's on pin 13 on the chip, and it's an output. It's information leaving the chip. This runs once, it's like building a road. This runs over and over again. It's like the driving instructions for driving on that road. I'm gonna digital write or turn LED high, right? I'm gonna say digital write to pin 13, a high signal. It's like flipping a light signal, a light switch on. I'm gonna wait for how long? 1,000 milliseconds or 1 second. I'm going to turn it low. I'm going to wait for 1 second, and the whole thing's going to start over again. What happens if I change these numbers and reload the code? Anybody? Bueller?
It blinks faster?
That's right.
Slower?
Yeah, right. Exactly. Perfect. Okay, good. Thank you. You're taking off. Okay. Any problems? You guys have changed the blink delay. Have you changed it? No. Good, good, good. Any problems? No. People are building. Okay. Cool. Okay. So you guys have already started on the build on the chassis, and I'm going to let you keep running with that. As we go through this, there are 2 3/4-inch standoffs, which are going to go in this position right here. You're going to mount those with the 1/4-inch 440 screws. So these 2 standoffs are not included in the kit instructions, so we need to add these 2 things right here. And I want a donut. What is that? He wonders out loud. So there's 2, there should be a set of 1/4-inch 440 screws in here. Yep, those right there. So can I see that for a second, Liam? So the screws you're going to use are not included in the kit. The standoffs and this little bag of screws are in your box of parts, but they're not part of the Dagu kit. So we want this 1/4 by 440 screw to set those standoffs on. Oh my God, what a donut.
Not right now, we'll just see. We want to see what's going on.
Smooth side or textured side or loose go on or device manager.
I think it's should be interchangeable. Yeah.
Okay, so the standoffs go in one of these.
So if you look at the orientation on this, you're going to take the part with the square knockout, and then they're going to go here and here. So there's only one place this can go on the Dagu chassis. In the back, by the square knockout, are 2 holes next to the slots. They're the widest holes on the board. You have to put these in the widest holes available on the board. So they're going to be as far apart as possible. I would put the battery thing on now, please. Yeah, there's a bag of small screws in here. There should be. Yep, there they are. Right there. Perfect. Yep, but you want the, and you want like that. So you want the battery holder on the same side as the screw. That's the standoffs. Yeah, they are.
So does the battery thing need SparkFun supplied hardware too?
No, it does not.
It came with its own.
Yep. So pay close attention that the standoffs on the battery holder are on the same side of the plate.
I was running XD, and for some reason we're not able to do download from the Arduino file,
And I'm sure
from the Arduino drivers. So
because that's like a lot of times when stuff
This with the
ability things is usually there's some type of administrative privilege and stuff. We can't get it to work.
okay.
Is this enumerating on the comms?
FTDchip.com.
So go to your Start tab. I just want to see what the problem looks like here. Go to Control Panel, System. Okay, right-click on the USB serial port. Go to Properties. Go to Driver. Go to Update Driver. No, not at this time. Next. Install from a specific location. Now, browse. Just click the driver tab. Just drivers. Click OK. Click Next. Continue anyway. Did you guys go through this twice? I don't want to restart the system. They need to update on the restart. So go all the way through and then restart the system and see if that doesn't. We can give you go up. Yep, that's no. Go up another level. Keep going. Hit drivers. All one right there. Nope, just drivers. I think you're too far into the file. The driver's install on this machine. Okay, yeah, try it from FTDI. See if you can get it to point to it from FTDI chip. Because your install won't let you select just that. And you did you do it's too far now. It's because it's going to mess yeah, it's not letting you install or have access to it. Yeah, try it from FTDI chip. Otherwise, we can give you a computer chip. So if you've gotten through the top plate ones, there's two more that we're going to set right here. Too small. standoffs, 3/8 standoffs, and Derek's going to hand those out. And they're going to mount with the 1/4 inch 440 screws. Go to Amazon and get a TP-Link MR3020. They're $30, and everything is like an open source download from Library Box. They're cool. They are super cool. And do you know Pirate Box? This is an outgrowth of Pirate Box. Pirate Box is both ways. You can load data to it and take data from it. So we just configured this so it's just download. Nobody can load to it. Right, but Pirate Box is open wireless and you can push to it or pull from it. We're actually trying to configure them for live data channels. So they serve as a wireless data channel, so we can do a room full of people like this and do live data wirelessly from everybody's computer.
There's 2 wires.
Okay, cool. Yeah, thanks. So far, it's not so bad, right?
A little hiccupy, but that's okay.
That's the driver's stuff. That's always the driver's stuff. Okay. Got it. Standoffs.
Yes, sir.
There we go.
Don't need a pair too.
Okay, great. Where do you go to school? Where's that?
Thank you very much.
This is South Boulder.
Okay.
This would be called a handout.
It is. There we go.
Yep.
Who else? It requires the little standoffs. Okay. Okay.
These little things are gonna be the death of me.
You guys getting the short standoffs yet?
Yes, yes.
I'll help you in a minute.
Yes. Okay. And there we go. Those are your standoffs.
Which one is my favorite number?
But 1 is the loneliest number.
2 can be as bad as 1.
Yeah, but 1 is the loneliest number.
Number 1.
Yes. Yeah, there's 10 bags of short screws. Should be 10 bags of short screws. Standoffs. So one more thing to note on this slide, as well as the standoffs that we put on the top plate, there are 2 standoffs that go on the front of the robot right here. And I would finger tighten those so we can slide them in and out to make for the sensor. You need the little ones. No, we changed this yesterday because we were...
I think I have most of the pieces.
That's weird, that whole the whole driver XP. Yeah, the installer's just not pointing to it. No. This is extra parts. Sometimes I just have extra parts. would you guys do me a favor? If you do build a library box or a pirate box, tell library box that you saw the project and that you're pulling it and working with it, because those guys are like, they're really cool guys, and we want them to know when people are using their stuff.
And before I leave, I'll write that information down.
Yeah.
That's the front door.
Right. The other thing is, like, even if you do forget, all you got to do is go to Library Box, just librarybox.org, and it's all there. Yeah, it's like all the XML. Is it, Derek? That's all Library Box running on XML, HTML. Yeah. But that's a great blog post, actually. Building SparkBox would be a... Yep. It's a phenomenal tool. Mine's right here. I don't... Yeah? Hey, Mike, are you tweeting? Would you include @LibraryBox on that? Right? Because we're running this whole class off LibraryBox. So, I know the donuts are fantastic. So far, so good? Hooray! You're a great audience. Do you need another set of hands? You good? You're pulling the library? Yeah. Okay. Good.
Wow. This is so impressive.
Grace? Is that Grace? Martha. Yes, ma'am. Yes, as long as when you mount this, it goes like that.
Oh.
So far, our schedule is like to the minute. That's insane.
And that's with you would have been at this.
We had, yeah, but it's going to take longer to build than I think it is. It's going to take 15 minutes longer to build than long it is. And this poor woman with her kid at the end of the table. If we get her through this day, you and I both have a guaranteed spot. Right. Thank you. Hello, Rosie. Come here, sweetie. Yes, it's okay. I know. Hi. So Rosie traveled the country with us in an RV. Oh, nice. Yep. She was the only dog to go on tour with us. She was awesome. She's the most perfect dog ever. Go on, go be famous. Okay. What's the left? What's the left? Oh, Rosie. Are we on, so we're on the SparkFun YouTube channel? Okay, cool. Did you use Chrome? Yeah. So go to Chrome and click on the keyboard.
I'm just trying to import the file.
So wait a minute. Oops. So you're going to import that.
RedBot files in the library.
So it should be, there's, in my documents, there should be, this is the file right here. Okay, and you put it in the libraries folder. So you're going to take this whole thing right here and import it into libraries. Yep. Everything, go up a level. Okay, now just take that, put it in the libraries folder. And finally, before you put the top on, we want to make sure that there are 2 3/4-inch standoffs on the bottom of the chassis. So I've got everything on the top that we looked at, and before I put the top on, we're going to flip this over, and these are the 2 that you have on the front, and there's 2 on the bottom that go right here. The build I'm sorry? Oh. Yeah. This side's the front. So you're going to put those right here and right here. Okay. Or wait a minute. I think it doesn't matter whether it's here and here or here and here. You're okay. You should be all right. 440 by quarters. Leah, move those to here. Switch. Quarters. 440 by quarters.
I just realized I was around and I had a certain amount.
Okay. No problem. So are you ball? Are you a ball? Yeah.
No, I recognize that.
I do know Tom. What's Tom up to?
Well, he's using it right now, flying a drone over the
Tom has a pretty good life.
Yeah.
What do you, is it? Are they doing survey with the drones?
Yeah, we started at
What are you guys flying? What are you guys flying?
He's flying Penguin.
No. Because I've been flying the DJI stuff. Do you know that? Like the flame wheels. So we're flying both Parallax and DJI at our house. No, the actual flight platform.
No, yeah. So he flies Penguin and a double. The split fuselage things in the back.
Yeah. I know that one because the guys from the commercial fishing industry are using that. That's the one they're hooking on the mast.
Oh, yeah.
Have you seen? Yeah. How's that going? Really? Oh. I was interested there for a second.
Oh, no.
No, I was up flying at 5 o'clock this morning, actually. Nice. So, okay. Perfect. They say. Oh, that's because, wait a minute. Hey, Derek. We got to change the posts on the bottom to 3/8, yeah, half inchers, because we got different tires on this one. The call out for this. Three-eighths. Yeah, no, there's some, there should be some in there, I think. There's some right here. Let's double check really fast before we change everybody out. I thought we spec'd those big tires. Those are good? Okay. All right, so we're gonna. So I got a quick change. There's a difference in the tire size between what got spec'd on the build sheet and what got spec'd on our prototype. So we're gonna have to change these two standoffs from 3/4 to 3/8. So we're gonna push you guys 3/8 standoffs. Sorry. I know, right? So the ones on the bottom are going to go to half the size. No, they're, yeah, the bottom of that one. So I'll give you 2 3/8. There we go. There you are, sir. Okay, so I'm gonna give you guys 2 3/8 to do. Those are the ones that go on the bottom instead of the long ones. Thank you. Leslie, I'll be right back. Yes, sir. Yep. Yep, just double click that. No, okay, go back. Yeah, just, yeah. Here. Would you make sure that everybody has 3/8 standoffs?
Last is keyboard. You guys get extra credit for this.
Robert's stronger against me.
We actually need
Great, perfect. Okay. Hey, Matt. So what I did is just pull this out here and right click it. And it says extract all. And I click that extract all and I point it at the libraries folder. Okay. So is this computer going to you guys? Okay. There we go. I do. I'll be right back. You're welcome.
So the ones that are on the gallery. Hey, Jeff, can you move the mouse?
Oh, there. Yeah?
There's some line follower sensors. Doesn't need to be the short.
Minutes extra. Okay. Figure out how to. Should I be building this at the same time? They are pretty nice. Multi-chassis Dago.
Well, the problem is like, I looked at the footprint, it's like, it did the same thing. It's the same design, right?
Except this is, well, Dago makes RedBot as well. They make the Magician's chassis, and they make all these cool metal chassis. These metal chassis are so much better.
I mean, it's once they're together.
Yeah, but this thing will run outside, too.
Any suggestions on how to get your motor wires out of the enclosure? Any which way you can?
You're gonna go up through the top,
Right.
and there should be like kind of a little hole in there, and then what we're gonna end up doing is
Clipping these back and putting the reds together and the blacks together on one side. How's it going? Oh, it's going really good. Okay, awesome. Awesome, perfect. Do you need? There should be pliers in the bins too. But what we need to look at is strippers for people to cut and.
You guys want to borrow our Arduino?
yeah, please.
Very useful.
Sorry. Strippers. I thought we had strippers. Do I need to pull some from stock? Yeah, cool. Okay. I think there's extras. So just a quick note while you're going through these builds, you're going to end up with some extra parts, and that's okay because you're going to iterate on this thing at some point in time in the future, we hope. So don't worry if you have extra parts. We do that. I'm sorry? Okay. Do you need 3/4 or those can go? And we have extra screws. So if we, yeah, we're gonna hold. You should have 3/4 left, right? No. And are you sure we got everything out of here? I'm just checking. Our build on this. Yeah, there's those are 3/8. It's okay. It's okay. 3/4. Yeah. Right. So don't worry about it. What we want to do is we want to get to the point where we can start loading code to the bot and putting wire strippers on. So. No. I left my finished one at home. I know. I'm just gonna. Do you want to build this one?
If I build it,
they will come. Here. Why am I doing this? Do like right here, so that there's a whole box of parts. This is the build right here, and that's my personal robot. Like I bought that robot because someday we're breaking up and I'm taking the kids. Right? That's what I tell Lindsay. She's like, why do you buy hardware on your own code? Because I'm leaving someday and it's going with me. Totally? What's why? Do we have them?
No, go get it. Yeah, I'm gonna go get it.
Okay.
I just ordered a class.
Okay, cool. Yeah. Nice. So if you've gotten this far, what we're going to do is Derek's down grabbing some wire strippers because our wire strippers are out on a project right now. But we're going to take these wires and we're going to splice them together. Each side goes with one set of wires. We have 2 sets of wires on each side right now. So red and red are going to twist together. We're going to cut the ends off them, strip the wires back, and twist them together. Black and black go together on each side. So the whole idea is that the 2 motors on each side turn together, run by 2 wires only.
Yes, those wires. You can actually use your router.
Bolts. Which bolts? Those, no, those we don't have extras. Why? Are they missing? What, where does it go? Show me where it goes. Like a long one that goes through the top right there. I think you're all right. No. Let me see here.
Hey, Chad, we have to cut the little burn header.
You're going to have to cut the existing headers off them, strip them back, and then twist the colors together. We will fix this. Hang on. I got it, Matt. It's too big for, let me see. Okay. Okay, there it is. Hey, Matt, just give her one out of your kit.
Just slice them.
Why? No, you can still build it. Just put it in there. Yeah, it'll be fine. So you're going to split up by side. So the reds and the reds, you're going to cut the ends off of here. The reds and the reds will go together, and the blacks and the blacks will go together. And same thing on the other side.
It is. It's a good sentiment from my father.
arm on. So I got Derek's got strippers right there. Really? Oh, because we ran out of everything on the shelf. How many did you get? Awesome. So we're gonna loan you a set of strippers. We're gonna give you guys, we just got a classroom set of strippers. Please return these when you're done. Okay. Okay. There we go. Okay, you're good. Okay. Okay. Good. Right. Now, don't use your teeth. What? It does work. So now you can't have them, isn't it?
So we're going to give you headers.
Yes, we're going to give you headers. So, in fact, I will. You're welcome. Got him. Got him. Angela, you need. Cut both of them. Cut both of the heads off them. Strip them back. Twist them together. We're going to give you male headers. So I'm going to start trimming headers and handing them out. Give them short.
Should we like eat this? How much?
Guys, make it on your soldering.
Gentlemen, are you enjoying yourself?
Immensely.
Awesome. Almost lost. So where are you guys doing? I'm not going to film
So, a moment before you guys get too far ahead, let's get you some shrink wrap. There's a bag there. When we solder these on, we don't want those connections kind of crossing, so we're going to clean it up with shrink wrap. Slide shrink wrap over the solder joint, so we have shrink wrap. We'll trim it to.
Do you have lighters or anything?
Soldering irons, don't use the part of solder, use the barrel.
Short ends, so you can actually take fire out too.
Oh, here we go.
Oh, yeah. So you got your wires stripped back. We want to make sure you get your shrink wrap to cover up your solder joints. And then Matt's going to talk about soldering for those of you who is maybe your introduction to soldering. We need 2 steps. Here is iron. I don't know which one. No, like that. Doesn't matter, you can cut the shrink wrap with your snips or your pliers. There's power on your pliers as well.
We're going to run out. Slide a piece of shrink wrap back away from where it's going to get hot, because if it gets hot, it tightens up down here. It's no longer of use to me. Then I'm going to take, you guys have third hands in here, which means I'm going to take this little doohickey right here with the wire clips. I can hold the wire with one and the header with the other, position it, and do the soldering. And Matt, do you want to? So Matt is a Miltech certified solder technician.
Nice.
Right?
This is a tube of cardboard with a little cone on it, but right now we're going to pretend it's soldering iron. Anybody here not soldered before? Soldering irons are hot. Do not burn yourself. Stop. The way you're going to do it,
Here, I'm the annular ring. Okay.
you are an annular ring.
Yep. So, all right, here's my pin right here, and here's my two wires.
And this is solder. My left arm is solder. And this is the soldering iron. We're going to shrink down a little bit. Okay. So the way you want to lead your solder into the side tip. Not right at the tip, like right here. And so you go to your head there, and you bring the solder in, and like this, and it'll feed in. You might have to hold there for a second, but it'll start feeding in. And lock all the solder on. And watch it come out. We're not going to use a magnet. Something like this. You're not going to have a big ball of solder, but naturally, just
Right. No, there's no. It's the solder will do the business. So we go to the short end of the pins. Like if you were wondering which side do I solder to, we go to the short end of the pins, and then we cover everything up with shrink wrap to keep it from shorting out.
After we have the solder.
Are they coming out the sides?
I'm on my way. It'll start thinking I got it. I'm going to pull it. Okay. Take it. What did that handle? Solder. But really, the way we're talking about solder. Solder
What is solder?
Yep, that's solder.
Why do you use solder? Why do you have this?
Cannot touch. Remember, they cannot touch. We need the drops in isolation. One wire will go to one side again, and one red wire will go to one side of the other. The black wire comes in again, will go to the other end.
You just want to connect this to one pin. And I'm going to just fold that back like that. So I'll make that solder joint right there. And then solder that like that. Right, so if you take the arms on your third hand and bend them in like this, you can use it to hold both sides.
And make sure those are going.
This is all built. Are you rocking, young lady? Is this cool? This is a build. I did. I hope. I mean, I'm just checking something on the kit. Okay. Okay. Yep. Okay. What? Yeah, right? Because there's no more important piece of safety equipment. Yep. Don't. Is that Dad? Don't let Dad burn himself, okay? Like, you're the safety advisor. But as safety advisor, when he starts soldering, those go right there, okay? All right, rock on. And Dad, so there is no more important piece of safety equipment when soldering than safety glasses. As someone who has had 5 eye drillings as a result of metal in my eye, I can tell you it is memorably unpleasant. Memorably unpleasant. Oh, I don't want to, Angela, do you want to tell? I want to hear from your perspective.
I didn't witness it, I just heard it.
So at 5 o'clock or 6 o'clock in the morning last week at South by Southwest, I blew a battery up in my face, and so I had hot solder and battery acid all over my face. Not good. Yeah. And I just had like a whole thing of headers. There's, here, I'll be right back. Safety glasses. Science fiction, cars continue buying motorcycles. Yeah, like that.
Yeah, that's the way I heat you. Way to go.
Kind of like the fingererizer. No, I just use the soldering iron. Why get out another tool? Heat shrink with the side of the soldering iron? Yeah.
We have bagels over here that are woefully lonesome.
So when you phrase it like that,
Right? Nobody loves bagels. Poor bagel. Living in the icy shadow of the dome.
Grass story.
The little bagel that is delicious. What's the bagel letters? Cheesy puffs. Cheesy puffs. What a bagel and cheesy puff.
should you grab that?
Grab it by the wall.
So, got your pin, solder, right? Okay, so we put the sleeve on first, but I think we're okay. Where's your, did you get, no, the heat shrink. I thought they walked around with heat shrink. Here we go. Here's some heat shrink. Yeah. We're going to give you a slightly larger piece. Yeah, exactly. Yep. So I'm going to take this and I'm actually just going to slide it over because this one will fit over here like so. And then when you're done, you're gonna take the side of the soldering iron and just heat it up. But before we do that, we're going to take a smaller one. Yep, and I'm going to give you a whole tube of smaller shrink wrap. So that will go over every set of wires. So then you can cut it with the, yep, take that and cut it into 4. Leslie, how you doing? We need more room. This is crowded. So then, once those are done, then we want to make sure that we got 2 pins on the power, right? 2 pins for the board. Okay. Little Susie. It's all right. run straight through until everybody's robot is built, and then we break for lunch. You know what? It's easier to pull. But we have a slot. Yeah. I got it. Sure. How come I can't? I need secure on here. Okay. Okay, that's all right. You don't even need it on there for right now. You can slide it back out of the way, make your joint on this one, right? And so what I would do is probably pre-tin the wire. So, yep, I'm going to clean this off. Is this thing on? Wow, that's hot. So I'm going to tin this one. I had like big shrink wrap, and it was like the same color. I can't really like see it from here. Yeah, but there, that's the general idea right there. Okay. Yes. Okay, so great. Yeah, it just due to that, like, we realized that, like, we kind of opened this up to 2 people per space. And then we were like, oh my God, this classroom's really full, like, at the last minute. So that's why it's so tight. We usually limit classes to 30 people. And I think we're well above that right now.
Soldering. I would like far down.
They were supposed to go on the bottom. It's all right. Don't worry about it for right now. We'll get to it. We'll still do it.
I do mainstream. I do all my measurements in Kelvin.
Wow, that is 2003.
Right? No, it doesn't matter. It didn't, like, once you get it plugged in, it's fine. And they'll slide back and forth in there a little bit after you heat them. It's all right. Yes, sir.
So,
Yep, that looks good.
So what we're gonna do is slide that on a little bit, and take the pliers and kind of give that a little tug. There you go. Yeah, that's good. Perfect. Thank you.
Yes? Okay. That didn't take any time at all. I'm sorry. It's full of lead, absolutely full of lead. All this pernicious nonsense about lead, it's totally wrong. It should be on SparkFun. It's on SparkFun. Intro to Arduino, get licensed. RedBot Code Library. Sure. This looks good. Okay. Anybody want a last fiddle? Barrel Jackson kits. Okay. So we take these and then one side of that is going to go to the other side. It's going to go to one side. So I'm going to satellite this. And I'm usually putting on the outside to keep them away from each other. And then the other side will slide over there. I'll slide the shrink wrap over, pick it up, and I'll cover the three joints. Good. How you doing? We're all together. We're good. Is this a world dominating robot? Not yet, but we'll be by the end of the day. Yes, sir. So once your headers are solid, right, you're going to slide the shrink wrap up and cover up the wires. Okay? And then if you heat it with the side of the soldering iron, not the pit, but the side, it'll close up on that. Keep them from touching each other and shorting. So we're thinking we're going to get it with robots built kind of quick.
How do you not need to throw them? If I was trying to throw something out of things, it's like this is an intro to robotics. David Wood. Oh. So I try to care like people think about it. You would go to mechanical components, there's coding components.
Sasha, that looks excellent. It's really nice. This is good. This is good. You get an A+. Awesome.
Really liking it here.
Yep, nice job.
You could get a job?
You could get a job here. Yeah, walk by Angela on the way back. Check her hair out. She's got it. Matt is, but this is God-given. Did you?
So what we normally do is get away from it. Like
Yeah, I know, I saw that. I thought it was Bob.
Yes, sir.
Hope it doesn't do anything bad. Yeah, I know. Oh? Not yet. Not yet. I don't think it wants to do anything.
Long
Oh, okay. Cool. So after this, I would do the barrel jack slide. The barrel jack. So that you're gonna snip this off and treat it just like you did the other one. Oh man. Now I have a vehicle. So now we're gonna No. We just did this one. Not in there. I tried to unplug my picture.
So there's one final soldering operation, and that is to put the barrel jack on for the power connector. So on the end of your battery pack, we're going to cut those wires off. We're going to strip those wires back and, come on, projector.
Do you think the bulb blew?
No, it didn't. It's good.
It's center positive. So the red wire goes to the thing that connects to the center of the barrel jack. And we're trying to get the picture up right now. Come on.
No. That's one thing we need to have.
Yeah.
It's an extra bulb.
So you can see in this picture how my red one goes to the tab that connects to the center of the power barrel jack. Before I solder anything and before I hooked anything up, I want to slide that sleeve over the wires, because in the end we're going to pull that sleeve back. So put the sleeve over the wires, then make your connections, making sure that the red goes to center.
I should have taken a picture with.
Where does the red go?
Center.
The red goes to center. That's super important, otherwise things get hot and smoke comes out of them and it's a bad day.
Robot friend, you release the magic smoke.
That's right, the magic smoke floats away. Good, you feeling good? Okay, so we can take these, and we can take this, oh, could you turn the soldering iron on? Yeah. And we're just gonna take this.
Anybody else do the barrel jack? Look at that. Half the kids have them, half don't. Barrel jack. Barrel jack.
So some kids have them and some kids don't? Nice.
Who else needs a barrel jack?
You got it? Can you do the other one? All right. What are you doing for shrink wrap? Yeah. I just use the side of the iron. We're hacks. Some had them, some didn't. This is kidding. Are you kidding? This is terrible. It's not just so in your kit is ready to go. So that's your kitting. So what we're going to do is
Yeah, as long as things aren't touching, they're not going to touch your main thing is make sure you get that barrel jack sleeve on the wires before you solder anything. Robot has a third hand. Hey Matt, it's right there on the bag. Shinier is easier to tell.
With XP?
How's the tip of everybody irons the brass sponge?
They're trying to get all our classes recorded to video, so that if you miss stuff, you can just like kind of pull it up like a video library.
I always want to group it like
You're right, yeah.
They're behind
How are your soldering irons doing, guys? Are they dirty?
They're very hot.
Well, yeah. I just look at it. It's been on for a while, so I'll make sure we're.
Hey Jeff, did you get more number 4 fasteners for mounting the Arduino?
You need 3/8 screws, is that right?
Did you go get screws?
I have some, yes.
I had some.
Yeah.
So, does it matter which?
Yeah, you want these ones.
We don't have any more screws though. The other ones don't work. I tried.
If you're looking at giving me that student look that wrote something, okay, perfect.
We don't have that. I am.
Oh, no, yeah. Put on your...
Are you using scaling because you gotta get that barrel back on? If you guys are working on the barrel jacks,
and you feel like the wire's a little long off of it, and they might end up touching, I have some electrical tape. Just want to use it sparingly so we can get that sleeve back over, okay? This.
So what's going down now? Oh yeah, we need to put those copper gold you can screw them from the bottom. And then the top. And which screws? These black ones or the round ones? Want to do the round ones? And then you should put them at the front of the back. Like, I mean, they work a little bit, and then got super powerful microwaves. And then the other two right here. And then a resetting. For one back. So you don't have to. You didn't put them where I did. Oh yeah? Yeah, I'm trying to assume they're not going to. No, they're not, I guarantee you. I tried. I stripped poop out of one of the screws trying to get it out. No, give one to every person.
Oh,
Yeah, yep, every person gets two. Yeah, they have 2 kids. So is SparkFun like just an older thing, or? Yeah, just the one.
Extra. So you have to read it all about them.
Obviously the automated fully operated mount turret. No. Like the way the battery sits in.
So, yeah, so we just want to go a bit more of a... Yeah, I don't know if we're doing it right now. Those are for mounting certain...
Yeah, this part, you can throw it up right. The same thing as that. It should also not get away with parts. Ready?
The power data is going to have
Is it cool if I screw the top on? My,
which makes it fun, right? So you go to your box. Red box.
Oh, there's one.
Yeah.
I got Jack. No, I mean, there's a battery box.
Okay. Oh, yeah, that's what wheels on?
I got some. Okay, perfect.
You guys want to borrow my laptop for a second?
Yeah, because they have to be on the side of that. I found that screw that yeah, trying to get it out of one of these. Oh, yeah. Me too. Follow the example of Bob. Just like in computer science.
We have friends in Hawaii.
No, I get the lag. We're just shooting here in Hawaii.
People flying drones real time. halfway around the world. You have to have a dedicated, you know, frequency for it, but there's the guys, so we do some work with the Navy at Patuxent River, which is the Navy's drone facility. And they say there's about 200 milliseconds of lag. I mean, it's, you know, there's that much lag. Well, they're running satellite, but they're running directed frequency on the satellite. Radio waves are traveling near the speed of light. I think. Right.
I had to use the
So they said that the guys, the pilots, said to me it's about 200 milliseconds. So one of the like defining moments of my time here was walking into this hangar full of predators and global hawks and just going unreal. Is it not making? If it should be all right if it's tight. Okay. You trim it back a little bit. It works. Okay. You can put the spacers wherever you want. These are the widest points, and they match the holes in the PCB. Cool. That's nothing smoking. Okay. So here's our plan. Is we want to get everybody with a finished bot. We're going to break for lunch. When we come back, we're going to start programming the bots. So we usually go 12 to 1 for lunch. I think we're a little past that right now, so 10 after 1. How many people still need time to finish the bot? Most people, okay. Okay, all right. Holler out. Take it. Oh.
So 20 minutes will get us 12:30. So I think most people are kind of in that definitely be done by 12:30. So we'll go 12:30 to 1:31. You guys got it?
So we stretched ours and it fit. I don't think there's any reason why you mount the other way.
It's a quick fix. Oh, I think that's. How do you know? It's like we have like Wait, you should have those too. Yeah, you're gonna be like, yes, they want the back and want fire separate. You didn't. Geez, Bob, freaking me out.
And it said that in the presentation.
I don't know what that term.
Maybe they renamed it and they haven't named it.
Science. We don't maybe we just go in a straight line until we die.
No, that's not. Those were all my effort.
Yeah, and what we did, we just
RedBot.
I built our own website.
Yeah, it's under Arduino RedBot. I don't know. Well, there's all kinds of RedBots.
I'm sorry? I think we may have actually Yes, you did. So this side has to be split out and that side has to be split out. So you're going to have to kind of carefully clip those back. And I'll give you some scissors to slice the. What did you solder on? Oh man, all of us.
Can we go to lunch?
You can go to lunch. Yes.
Thank you.
We soldered ours wrong. Turns out. We did our I was listening to what they said. Yeah, I'm pretty. Well, you have a picture? Okay, hold on.
It says website and motors together.
Wait, this one's cool. Yeah, that was good. Ah, I'm gonna stab you.
I think what's going to happen is read
Should I just cut the grab off? That would be glorious. There. Bring that up here. Mine just, mine title.
Okay, never mind. He's not done using it.
Oh, word, my shrink wrap just split off. You want to fight, Doran? I'm going to take this top off. I don't want to do this wrong. This top off. Yeah.
Yes, you can have assistance.
What's that?
So can I just put the solder on this top of the parts?
Sort of. There's a sort of point with the
I'll give it a try. Not, I mean, my wires are tiny.
So we cut it back, it still doesn't work.
Oh, it didn't work. You just have to do like this. Hold straight from the middle. Yeah.
And are we going to do new?
No. So you can try this wire.
So yeah, about that, John.
Shut up, no position.
I don't know. I mean, I was able to see.
Hey John, don't you need to take these apart too?
Yeah, I was going to do that with the soldering iron.
Oh, the yellow two?
Well, no, not those. He said he was bringing around scissors.
Oh, I have some scissors. Wait, do you need some? Scissors work here?
I have no idea.
Does that help?
No.
Well, no, the head's
Yeah, that's right. You saying something, Mr. Rocket? I dropped it.
Make it longer.
Jordan, how much longer until you're done with that soldering iron?
Like 2 minutes, but if you keep asking, it's going to be a lot longer.
Don't worry, I have them written down.
All doors falls.
Any barrel in there? Okay, sorry.
She would go and shut off the stream. Just down to Windows, so you put it in the right way. Let the battery pack large. But we're also teaching. We're doing some directed classes for this again.
How's that in your
So I don't know much about
Mine's still a little tiny. That is like 2 inches.
I know, but I'm not even other.
Yeah, and then we're gonna have to add some to our power cable as well.
Yeah, that's like runs it into something. Yeah.
We'll probably have more.
Here it is.
Thank you. Thank you.
No problem. It's nice to be able to get this. Fingers crossed.
Soup.
You want chili, Matt? You want chili?
I got food.
All right.
Yeah. All right. Thank you.
No problem.
So,
Do we have extra water?
yeah, we'll just strip, cut it.
You said, what'd you
Strip it both sides. And then you already have barrel jack connections, so just cut it. Barrel jacks, like in the middle.
You better have like 3 inches, because I added about 1.5 inches and it's still pretty tight. Yeah, pretty much.
Yeah, and then you'll just wrap it around. Like you did with the other these wires. Not too far in each, do it right in the middle, because you just want to extend it. So you want enough to be able to.
So wait, so you could,
Strip this side.
so you could make that work with that side?
Right. I don't know. Yeah, that would actually. I should do that.
Probably want to do some more shrink wrap on that. Yeah. Grab that. Get special. You don't need that long.
Something wrong with my
Good idea, Ralph.
Did you got the sensor wires yet, or? Which is everything? Did you add anything on with motors?
No, just that.
I don't know if they know it's this or that, but usually don't want to plug into the barrel jack to be able to use it. Yeah, I know it's like.
Blood sugar's low, we're not gonna use it.
So it's 5 volts. What? You get 5 volts plus 9 volts.
We want, you know how to do that?
Is there 2 on? Is there 1? Nothing to watch.
Yeah, no,
Oh,
well.
that's all, yeah.
Cool.
Well, 12 is my favorite number, so it's okay. Should we just go grab it and bring it back?
Yeah, we can here. Go down to 63rd. Left.
So my goal for this RedBot thing go that way and XP modem to set up a and then so that I can take a left wireless video camera. All I want.
Wireless video camera?
Yeah, just so I can have a little fun.
Did you realize the implication for what I was like they can do like 56 or 50
Really?
that means you'll get like 1 to 4 frames per second in like 360 by 480. Yeah, I looked into this wireless cameras, like real-time feeds. Wait, hard to do. The best way to do it is have a separate higher frequency RF Wi-Fi.
Sounds expensive.
Not too bad if you go from Singapore and are willing to wait. Like, I mean, like a little expensive, so like $50 for a kid.
Okay.
Plus power. And then the only other thing is antennas, so like better antennas. Will get you better radios. Okay. Clover leaf miles.
So then would I have like 720p?
No, it would still be analog, but it would be more continuous. And that would be
Let's do and come bring it back. Would that work, John? That way we can still finish. If you want to keep working, unless
Dude,
you
I'm not the
keep
one
working, we could bring it back.
Rossed up the
It's up to you.
motors.
yeah. Which one do you want?
Just do these two.
What do you think? If you want to keep working, we can bring you something back.
I'm just gonna solve it real quick.
Okay, no worries. That
Fun
works.
example and using it fun. No, I will.
See.
You give me a hard time all the time. Dude, go.
So I turn this off, right?
Yeah.
Good idea. I'll finish soldering that later. Oh, it's so depressing.
I know, right? Oh.
You just want to get it so there's no bare wires. You want the carrier on there? If there's anything that's weird.
You going back down?
Just remember before you connect it back here.
No, it's an eight.
Another piece of screwdriver on there.
You want to go outside?
And a different address and charge that, like put it in, okay, that's that. Well, that's. How's this going?
It's going really well. Like, we're gonna start offering more parent come solder as a family.
Yeah. That's a cool way to do it.
Just finished up yesterday, so of course everybody was like waiting until the very last moment to like finish designing and get things working. And,
I know that.
So we didn't really like have time to have an exhibition because I was like, I just finished it in an hour, but we ended up with some other projects. We're trying to, I think, beginning spring quarter we'll actually show together. So let you guys know. Yeah, I think I'm in the gallery for like April 14th and 27th, so we're going for an exhibition. But yeah, they ended up some really cool things. Also like tons of questions. Would you be interested in like kind of redoing a workshop in the spring? Or, I mean like so we start back up, this is our spring break this next week, and then we start back up, so it's like March 24th to June 3rd. So it would be something.
We have some travel coming up in April, so just trying to arrange it.
Yeah.
Like they're all the big national exams.
That's why I didn't invite you, just to see if you'd be interested.
Let me know if there's anything you want to change. Like,
I think kind of like even if we started off with you on the first day, and even like the more hands-on things, the first like just so physical circuit and talking to the group. Yeah, because the starting off with programming, it's like they're so tactile and visual that they really if we would have started with that, they would have start with Velcro and zippers and buttons and snaps and stitches and yeah. So if we start with that and the whole day and then either get more into that just actually physical picking up and then being like, oh, you need to find this issue or scratch or it's like just to I think if we reversed it then they would be like they would understand it more because it was so like abstract and like UI process. So I don't know if my computer computers it's like they have a hard time getting past that. But.
Yeah, and Jeff and I are going to be one workshop this summer and SmartFun as well as
For the summer?
Yeah, even live, but we're actually developing curriculum around doing wireless costuming as with different processing. So we're going to be working on that next.
That's what I want to do. I'm like trying to figure out right now. It's like, yeah, I've been playing around with some with you. I'm trying to figure out like the wireless component and I just can't quite figure it out.
We're going to be using Public XP, which is what we use.
Yeah. I picked some up and I started playing with them and I was like, oh, there's a lot of component right there. I really have to put some better resources.
We can really get into the wireless part because there's so much to cover.
Yeah, so that's actually really, I'm enrolled in a wearables class, the emerging technologies program at MTU, so I'm going to be taking that class this next quarter, so that's cool. So I think they're actually
what you're working on.
and that's what they're part of that, so we're going to speed in terms of that, detaching things.
Yeah, I didn't even
he's a software engineer, so he wants to build APIs for it and get a kind of web interface going. So he got to figure out the Bluetooth, and then we go from there. I'm like,
And it's pretty simple. It's just figuring out like in the code where you want to go. There's a video of this stuff, but it's basically a jacket with an accelerometer on it, and so there's a link now. There's the XP, and there's a breakout board for the XP that's sold, which is nice. And then so it's reading the accelerometer. And then that's just the processing. It's an audio. When you, yeah.
that's what it is. Like reality is.
So what do we do?
All right, no, thank you. Let us know if there's anything. Wow.
I think next time I'm just gonna get like toasted bread. We just pull down.
Thank you for watching.
What were you looking at for code-wise? Oh. We don't code what we eat. Did you just say that? It's crazy.
I was trying to find the dev offers for a while. Wow.
I know.
I also snipped this part off my barrel.
Yeah, more.
I also sliced it. It's relevant.
Hey, Jeff? Yeah? That computer clubhouse that Ben was talking about?
Robert.
It is Intel's computer clubhouse.
Kind of warmish. You see it's all warm and watered down.
Yeah, it's better than the other stuff though.
I knew it.
So we take some ultrasonic sensors. We didn't get that. Some ultrasonic sensors.
They did.
They did. Is it?
The sharp.
Is it?
Yeah.
Okay. Are we gonna put that?
Actually, no, it's infrared, but it does the same thing.
Okay. Yeah, I was thinking. That was about that. But where? Are we gonna mount it to this? So
I'm not sure, because it looks like we need that plate. I don't know if we can do that. Just, that's on there. That's around. Sorry, so this is where it's yeah, like, check the whole friends.
So about one thing, always try your drink before you leave the store.
Yeah.
And don't solder on it. It sucks.
yeah, don't drink solder either.
Yeah, we stopped it on the way back also.
No, I thought you should do that.
Yeah, it just kind of evaporated.
That's very good.
Yeah, Doran, I blame you.
You know what?
What's up?
You can go down the hole.
I probably could, but I don't think I will.
Okay, this is why we separated you two.
Pretty much. That's what teachers never realize.
That's just like in microeconomics, you're on like the opposite sides of the room and you just yell the whole time. No.
Math is fun.
Really?
That's why I like
Oh,
this.
yeah.
That's why I like Mr. Ziegler better than Mr. Fox. Because Ziegler's more tolerant and
Easygoing.
yeah, not mean.
I'm mean. I would rather be the mean teacher than tolerant. No, he's not here.
I'll take a minute to read out, by the way, if it's not.
I'll let it sit.
Weller stations, things sort of like that. They're pretty good. They're not too expensive. They're only like 130, but usually like much cheaper. And they're like that long. You don't watch the ones that are just a wire going to the wall.
What did I say to this guy?
Be patient.
Hey, John. Air hockey.
Soldering. Maybe.
Yeah, I know. I do too, but you know.
Someone sleeping.
Yeah. Pardon?
Someone sleeping. I had to wake up very early every day. And I've been on the go.
And I was so excited to like go to sleep early last night, and I didn't get home from work till like 10.
I was mad too. I like got in bed at like 10. I thought I was like, cool. That's like 8 hours or more. When I wake up, didn't fall asleep till about 12.
Yeah, I might have watched a little Clone Wars before I went to bed.
Just to start out with, the version 2, the one that we've been working with, it depends on what you want. If you want to use it like a micro PC, just kind of use your do software stuff with it, you can go with one. Version 2, they made a lot of improvements to it. It fits with Arduino shields. Mine has a like one row of computers, so it's all up here versus has a
I was just wondering, if this is a wireless camera, what do you think I need to get decent frame rate and stuff?
2 days.
Nothing else, I'll use some sarcastic internally. This guy? It's a separate battery. So it's 5 volts of overshield. So you get some,
As of now,
put that on there.
Probably
It's mine. So, but you can get this online for like $30.
40 pennies.
And then you see, you can just use Belkins and you software. But I also found processors library that use streaming video.
What they do is they go in character dashboard process. And they randomize.
And video and I roll the robotics.
So the rules are robotic.
Okay, so it's all one app.
Is it based off the Wi-Fi network?
And then you can put Wi-Fi module. They have a Wi-Fi module. So you can actually control through Wi-Fi and have a Wi-Fi.
Interesting stuff. And there are like lots of people complaining about it. Yeah.
Wi-Fi support monitor mode to do injection. This person will take the on this board to hack into private Wi-Fi stuff. Literally the only reason why there's like really.
You like the most people. Yeah, I got these signed prints for myself. Oh, by the way, you can have but still, I'm even. Is it a place you're in? You found it. Hey, that's just what we're doing.
Right.
I know you said that before. I'll help.
Next year.
Fly in. We'll make this happen.
Absolutely.
So if you're going out to Steve for college, are you going to be doing that Halloween ride thing again?
Yeah. I'm probably going to go there. I'm have to get over that. Well, I mean, especially not that much now that it's on there. But
You know what?
ways, like a way of doing outside. So, where it's highly much.
When I go in there, it does.
I'll probably find a day off. I'll be lying.
Yeah, it's like a small roller coaster. It makes for haunted house.
From FBI, you got
In a very, very nice house. Which is what you should be taking.
House?
Yes. Awesome. Yes, you should be taking the house.
It's common for my dad.
Astrophysicist, MasterCard. Yes. Average guy.
Oh, I'm gonna wait and talk to them. Go ahead.
He my dad or he used to do like scare houses, so they would put up scare stuff and they loved but there's also skill inside part of Arduino.
Arduino.
Yeah. And then like 4 years ago, we'll put it out. I have this house and this thing, his daughters just finished like going out to college now, so they don't have to force teenagers to work anymore. And so then he found me, and so then I started like using the background code live it last year. It was cool.
Exact same.
Jake and Wonderful Dragon.
Yes, it can be like a, this one you're talking about peanuts. There's like it's all on that
So was the mystery of RedBot, first robot, ever figured out?
On your slideshow, file this
Shrink wrap.
Yeah.
Shrink wrap. I don't know.
So the peanuts save. So not like peanuts. Yeah, it's yeah, like I don't know this. I don't know this.
Shrink wrap. The red and black together.
Better?
Huh? So, that's right, right?
Your hand up, Sadie?
It's not. Yep, so going through that.
I don't think that the library
Our website from SparkFun.
Might not be that sealed.
Sign on to SparkFun.
don't know if we are.
Is that working?
Hold it above your head. Victory pose. Victory pose. Yes, you're a champion. Awesome.
Did you verify good?
Yeah.
All right, good way to know, huh?
We still have 10 minutes. Leave them alone for 10 minutes.
Yeah. I'm trying to get into the SmartFun still.
What's up there, but didn't follow it.
Still need to get up.
I still need to look at SmartFun.
Okay, so I'm going to connect to it. Instead of this, it's a refresh.
Turn it on right here. The motor is on.
Yeah, that's right.
And even in my chat.
I've looked at one.
Yes? Is that excitement or like? Yay! Is that, I love that. Is that because something worked?
No, I failed, and I always learn something when something fails working first time, so I'm excited. So I thought I did what you said. I took RedBot Drive and loaded it to my Arduino. And I think the library's in the right place, but it's telling me RedBot motor does not name a type.
In the library.
Yes.
That's you.
So how did you fix it?
Okay.
So I think the RedBot library from Google has a whole bunch of documentation in it, and we have to figure out how to
Is it because the library is actually hidden inside? So I just need to go in So all you have to do is grab the CPP and H files and drag it.
I'd take a whole folder. You want to make sure that you're
Yeah, I got
Do we want to download it the way it is? Here.
Yeah, I think it is. Let me show you.
Yeah. So I have a
So then your library server under.
It's not connecting.
Oh, no, you gotta get the code off the RedBot website.
Okay, so our RedBot library folder that we have on SparkFun actually has a lot of other documentation in that folder. So what I'm going to do is I'm actually going to walk you guys through extracting and finding the actual library folder out of that folder and putting it in the right place. So the first thing I'm going to do is I'm going to click on libraries on SparkFun. It's an Arduino library, so I'm going to just show, and I'm going to download this RedBot. Most of you, or if not all of you, have already done this. So I'm just going to save this. I'm going to go to Jeff's download folders, download folder.
Power if I two power sources.
So, Derek, go to the button. Now right click.
I heard systems have issues with that. That's why I was like,
So I'm going to extract this file. I'm just going to extract it here just so you can see it. There we go. So this is the folder that you all have downloaded. And if I double click on this to open it, you have all of these things in here. So there's Arduino, documentation, hardware, production files, all of this stuff. If you double click on Arduino, this right here, this RedBot folder is actually the library folder that we want. Yep, so under Arduino, I'm going to copy this, and then I put that inside of that library folder in my documents. So if I go to my documents and I go to libraries, just like most of our Arduino folders are I'm walking you through getting the right one.
I just imported the folder and showed it.
So if you copy the folder in that Arduino folder and put it inside your libraries folder, is what you should do. You've got it downloaded.
The libraries folder under my documents.
So if you go to my documents.
My documents and then Arduino.
So you guys should have, here I'll write the tree up here. So what we originally had to do this morning was under my documents, you guys, we had, or added, so you should have an Arduino folder. And inside there, you probably have a libraries folder. We want to put RedBot inside of this. Does that make sense? But if you double click on RedBot, the correct folder should not have this is what it should look like. Oops.
Where is our example code? Just look it out of that, because I forgot to put all that stuff in the...
Libraries, or the example code right here.
Okay. Because we're going to need that.
And they just cut and paste it.
Do you want to draw it? It's on SparkBox. That's fine. So we're going to copy and paste from SparkBox.
Well, I mean, there's like 3 examples on there, but they're not good ones.
Yeah. So now, files and then example, the checkbox, and then select those. There's still, you got some here. Some of this is just can't file.
What? I thought I was done, but
It is. Does yours have the example files to it? I got the library, but...
No, so I got the example files off that bot website thing they got.
Okay, it's like a separate version?
Yeah, so go to this, click code, and then down at the bottom, yeah, show hide, you know, I can just exact.
just copy the small schedule. How did I get it? When sorry, hooked on.
So
what fits the,
oh yeah. So your library, where you hide your library? Show me where your, that I used to program it on PC.
Yeah, my stuff's there.
Okay, so here's Git. Click Arduino. Just take that. Don't do that because then it's going to be RedBot. So just take all that stuff. Control A or yeah, grab all that stuff and just put that under libraries RedBot. Right there. Well, I mean, the Arduino environment wants to look in your libraries and find a library called RedBot, and now it does because it's libraries RedBot, and there's all the C++ files in RedBot. Now it just hit the check mark and verify having
I thought it would get made into the file.
No.
So we're going to have to sign it.
I shouldn't, but I'm ready to go.
Any other SparkFun?
When did you install the Arduino environment? So that's the strength of
I have no idea why I have 3 Arduinos.
yeah, neither do I. But
The
it's
third one is what's open.
so that's yours.
So if I should
Okay, so, can I get everybody's attention really quickly? So we're going to get some code on these bots now. So one of the things that we've done is actually we've taken all of our example code that we're using today. We got it it's on SparkBox, and then we're going to get it up on our learn.sparkfun.com after today, so that if you need to access it later on, you can either save it to your machines today as you're working on it, but if you need to kind of find a fresh file, and for those of us that are joining us via stream, it'll be up on the site within this week. So, but first, we want to just get this robot to drive forward and stop, forward and stop. So what we're going to do is I'm going to go to SparkBox. And if you go to the code section, go to code, and I'm going to go down to RedBot, and I'm just going to show that code. And you'll see that there's 7 different examples there.
All right, so it compiled. It's on it, but I don't see any.
Motors run.
So we just want the drive?
So is it?
Oh, I probably need to actually change
batteries.
Yep, so let me just hit one last thing. There we go.
Are we just looking at the drive?
Yep. So just take drive. So the first one we're going to do, it's going to be a simple cut and paste. So I'm actually just going to highlight everything in this box. I'm going to copy it. And I'm just going to take it to Arduino, and I'm going to paste this. I'm going to connect the USB to my RedBot board, and then upload it just like you did the Blink code. We need to make sure that, so these motors sometimes and sometimes don't run off of USB power. So we need to make sure if we don't have batteries in it, we have batteries in it for it to run. And then we need to make sure, as soon as that's uploaded, switch the motors on. You might want to take a box or something and set it up on top of a box so it doesn't go running off the desk. Yes?
I just noticed mine was just spinning and I had to swap one side because the motors are facing opposite directions.
Yep.
All right.
So if your robot with this piece of code should just go straight forward. If it's not, you switch, you unplug one motor side and you flip it over so it'll, change the polarity of the motor.
Let's turn it off first. And let's get
that box motor, chemicals.
Yeah.
You're on the network, but where's
So do 192.168.11. So 192.168.
So if it's spinning, we just swap these two, or we just flip one?
So just do one.
Okay.
Just do one, yeah. Usually the one that's going backwards, you want to flip around, but we can figure it out. Yeah.
RedBot motor does not work.
So we were talking about the libraries folder, the correct libraries folder. You need to be able to do that and pull that folder in.
Arduino? That's all we had. Yeah.
So, libraries.
Highlight all that next. And then go back to libraries. Or not that library.
So what we're going to do.
You have 2 libraries there, I believe there's
paste it right there. Close your Arduino.
So what I want to do is. We're going to close Arduino and re-paste it. So close Arduino completely down.
library box.
Okay.
What do I do?
So go into your URL.
So, see, I've got this one still up, but
So click here. Put 192.
Oh, okay.
0.168.11, yeah, and it'll redirect you back to it.
Thank you.
Yep.
My thing's plugged in and everything's on, but it's not working.
Is there run on?
Is there a problem with that?
Does the light come on the board when it's powered?
Yeah, so it should be coming on. So.
Okay, so we have a power issue probably, or?
Yeah. And it might be in here. Something's either shorted out in here or it's the solder joint. So
our batteries look like they're in right, correct?
Yeah. Center positive.
Did our batteries run out or something?
That's right. That's correct.
So when you plug this in, the light comes on, right?
Sorry?
Plug this back in and just make sure.
Plugs in, the light comes on once I took it out.
Okay, so it's not the board.
That was crazy.
Where's Jeff? Center positive. Ground.
And then if you run it with it plugged in,
hello.
Show you that the software's working.
So you need to swap out. Let's see here. That this way's forward. So what we're gonna do is
swap out that left one.
That's the beginning of the communication line. Because remember you need baud rate to create that.
there you go. So that box is perfect for that, just sitting on it, right?
Where can we find the code?
That's the baud rate is what if you really download it.
So you remember Sparkbox?
It never works on my computer though, because it always says like when I connect,
Oh yeah.
it goes to that one tab and it says it's broken.
Click on that arrow. And then it's going to say, wait, yours is going to be named, so
Okay.
There you go. And code.
Okay.
And then what class are you in?
We are in RedBot.
Yeah. And then you can just cut and paste this code into your Arduino window.
Okay.
Okay.
Dad, can I have that cord so I can just plug it into mine?
done uploading right there.
Working again?
I don't think so.
So if you have your little kit box, the little red one, you can put it on top, or you can put it on top of. Yes, you can have them at the same time, yeah. It's working?
No, I lost my connection to the, so I restarted.
Let me just see this work.
Which test are we doing?
Just drive.
Just drive. Drive in there.
We don't have one in Drive in this library.
So no, it's off of SparkBox. So you got to cut and paste the code. So go to SparkBox under code.
Is this SparkBox here? Is this one?
Yeah, we should be on SparkFun. So.
There we go. So now if you go to code and show RedBot. Yep. And then just cut and paste it into Arduino. So if we go wireless. Come on. Crash.
We had it open, so.
Okay, so it is connected. We're just gonna do 192.1. So we're gonna go code. And we're gonna cut and paste, copy and paste this window right here. Control C. File new. Might have to do COM port stuff, but that's the idea anyways. AA batteries? Yeah, I'll get more batteries.
Is it supposed to be pretty snappy?
It depends. Which one are you working on here? So pivot. Yeah. So if you change from 100 to, like if you up that ante, so anything below 255, so like 200, it's going to be more forceful. Yeah.
And I copy and pasted it.
You just copy and pasted it into a new sketch.
Motor drive 255. So scroll up.
Yeah. It's gonna start going.
So you don't have the library.
Oh yeah, do this.
Yeah.
We're gonna get there. Okay, so we're gonna do a little bit of code dissection. I know I hear robots going, but I wanna take a look at this really quickly, just so that we get everybody's kind of brain in the same spot. So we have, at the top, if you guys are looking at your code, we have a command that says include redbot.h. What that is, a library file is basically just that. So it's a library, it's a collection of a whole bunch of code. And from that collection of code, I can actually go into a library and I can check out some books, right? Check out books, I can check out DVDs, I can check out all this other stuff. Same thing with a software library. I'm just saying this is the library I'm gonna go to, and now I can actually check out and use different code that people wrote. So library is a place where someone's written a lot of code for me already, and I can check it out and use it to write my research papers or watch a movie. If we scroll down, you see that I'm creating an object, and it's a RedBot motor object, and I'm just calling it motor. Could this be Fred? Yep. It could be John, it could be Jingleheimer Schmidt. But I just need to know that that's the name of my object that I'm creating, because down below I'm going to say motor dot whatever. So if you change this to John, you just have to make sure that all the code down below says john.drive. When we're looking at Arduino code, you have void setup, which runs once right at the beginning. And then you have void loop that runs over and over and over and over again, forever. So in our setup, we have this serial stuff. We're going to get to serial in a bit. We're actually going to use that to debug some of our sensors. But for right now, serial is just a way that my Arduino or my robot's going to communicate with my laptop. We're going to use it in a bit, though. In my loop, I have motor.drive 255. 255 is maximum speed.
I can't drive 255.
255 max. Delay means wait, right? Same thing as a wait command. If I told you to wait half a second, then you'd blink. So 500, it's 500 milliseconds, so it's half a second. So what this is you guys have heard motors go on and off. Turns on for half a second, motor brakes or stops for half a second. And then it goes back to the top. Drives for half a second, brakes for half a second. So what we can do is do some code manipulation. Instead of half a second, change this. Change it to 1,000, change it to 2,000. So that you're getting used to controlling this. You can also change.
This is like the blinky LEDs you're using to like the delay.
Yep. You guys okay?
Oh, no. Sorry, I had a question. What is... It says hashtag, or the pound sign include robot H. What does that mean?
So robot H is that library file.
So is that already included, or do you...
So it's not included normally, and then so library that include is saying, I'm going to use all of this code from this library.
Okay, because when I say upload something, it says all this stuff is wrong, but I don't know how to fix it.
It says the motor wasn't declared, which means you didn't actually.
So you have to go, scroll up, and you gotta.
Okay, keep going.
RedBot motor.
Forward or back?
Is there a browser?
You might want to check where his library file is. So you were saying you can't get yours going yet?
No, I gotta go.
Okay.
I figured it out. I had path issues.
Got it. This guy, you might want to move him up one.
If I move him up one?
So move it this way.
Yeah, but one wheel spins the opposite direction.
Okay, so instead of flipping it over, you just moved it down. Got it. That's one way of doing it.
So yeah, like the food for thought that I saw, the name of the folder after you unzip it, it's the exact same as the library underneath.
Yeah, I know.
So I saw people that's why I saw people, like, we got tripped up on that a little
Yeah.
bit.
Well, and because we downloaded it as just like, here's the library, because it's labeled as just the library, but it's all of our information for production.
Yeah, oh yeah. Yeah, I snagged it from GitHub, so it's like, but yeah, it's like,
yeah, much better, up to date.
Too much. I'm gonna check another.
Yours was running, right? Yours good? You guys are good? 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 No, not good?
It was working, we were afraid to change the value to 2,000, and it wouldn't upload, and we changed it back to 500. It was working. Why are you doing pivot too?
That's exactly how you're using butler and switch it. It wasn't one and then switch it together. So I think that's what.
Is your board on? So for you to upload, the board has to be on.
Okay.
And if while we're just debugging and stuff, you can turn the motors off. So done uploading, and now we can turn the motors on, run. There you go. No problem. It's a couple added steps on top of a normal Arduino. Anybody else need any help? We're doing okay? You guys all doing okay?
I think so.
As long as we can upload all of the drive and pivot and all that stuff, we're good. We're going to talk about sensors and all that.
Yep. Just want to get these things moving.
Oh, yeah.
You guys good?
Yeah, we're good. We're trying to see if we can go back and forth.
Perfect.
We're still on just this one. We'd be doing other things with our robot.
No, so you can change the time.
Change that to 2.
What happens? Can someone tell me what happens if I put a negative here? What happens if I put a negative?
Reverse.
Changes direction, right? It'll go in reverse. So we have forward and back. Jeff? Pat, PW?
Lydia, exclamation.
What?
Lydia, exclamation. Imagine yelling at an old cat.
Wow. Okay. Okay, so I think we've pretty much got these things driving blind. Now we're going to start including a little bit of smarts to this robot, because this robot's pretty dumb, right? It's going to run into things, go off cliffs, pretty much just keep driving. What we want to do now is start to include a sensor. And the first sensors that we're going to use are the ones on the bottom. So if you haven't added them yet, I would add them, and notice that the pins are facing forward. Okay, we want these pins facing forward because these wires are going to come out the front of the bot and back up to the top of the board. Okay, so let's get those mounted. If you have them mounted and they're facing the wrong direction, just loosen a little bit, flip them around, and tighten it back down again.
I still don't have mine running, and I think it's part of the library thing.
Okay. Huh?
Oh. Yeah, I think mine are backwards. Something around
These are long ones for small
As far as that line detection thing.
So you can black line on a whiteboard or
She's kind of after infrared.
I put them on. I don't know wire yet.
Right here.
Like the black wire, that's where the electricity inputs that goes in. Yeah, because the thing is, protons can't move. They're like jammed in there. The electrons move. And so the electrons flow from the we just didn't realize that for like 100 years. And so they say that's it. Yeah. I know, right? That is just awful.
I just clipped part of this off.
Taking that's the library. So put that inside the library. Each sensor, look at it really closely, has a GND, VIN, and what is it, val? What is it? What's the third value?
Out.
So out. So if we look at our RedBot main boards, and I'm going to actually go back to the slide that has So if we look at our boards, and I'll make this big. We have all these pins. So we have, some of them say servos, some of them say sensors. And each one of these columns of pins has an A number, so A0 or A1. 5V and GND. When you're looking at the sensor, you want to connect with the jumper wires. So there's double female jumper wires in there. Out goes to an A number. VCC goes to 5V. And GND goes to GND. Yes?
My double female jumper wires seem too short to do that.
Too short?
Yeah, this is all I got for double female. This long.
So they should be able to, because we... Yeah, just like that.
Yeah, and then the ends on the ends.
So I can't just put the top around them.
These guys are supposed to be here.
Yep.
Got it. Boy, that was.
I could do that.
So now let's talk about
Sorry?
The only command line I have, it keeps saying is already in use, so I can't upload anything more.
So when you hit upload, hold the reset button until, or when it's compiling, hold the reset button and then let go and it says uploading. You might get an error, but then try it again.
I got everything wired up. How exactly does the line following code work? Because currently it just kind of goes really fast.
because you need to go put it on a white surface. So if you go put it on a white surface with it straddling a black line.
So how does that?
So
That's supposed to plug into
these were supposed to be up here.
these guys.
So it's actually,
Oh.
sorry, if you take the top off and flip it around and put it down again. So like the,
Correct then? Or is it?
so this is the right way to have it. It's just the board needs to be, instead of above the batteries, it needs to be above here. Does that make sense? Or the easier thing would be to move these guys.
Yeah.
Yeah, that'd probably be easier for you.
We had fire over here.
Yeah?
Yeah.
What were you, Matt, what'd you catch on fire?
This was on fire.
Well, it wasn't on fire, it was melting. Not enough.
Kind of
Short?
Yeah.
Ooh, cool.
They need a prize for that.
I have an extra sensor because I only have one.
I just had one. Did I put it in my pocket? What's up?
I'm just following along in the slides on the slide deck, and it's almost like some of the slides are just kind of out of order.
Yeah.
You can erase it from your memory, like erase it from mine. Never happened.
So those of you that have your line sensors hooked up, you can also snag your breadboard, which looks like this. Can I borrow yours? And your blue potentiometer. And we're going to hook it up. So the way these breadboards work is that all the rows in a breadboard are connected. So for example, this row 10 for example, this whole row is connected right here. If I jump this ditch, these are connected here, but they're not connected to this one. So what I want to do is take my potentiometer, it has 3 pins, and make sure that each pin has its own row. So you can put it anywhere on this breadboard, it's just that each pin has to have its own row. Once you get it plugged in, you're gonna grab 3 wires. I would recommend a black, a red, and a yellow. That'd be my recommendation. The long ones that have their male, female. I'm trying to give you time to figure out people's software problems. Oh, that computer is like a tank. So I couldn't get in.
What pins do we stick them on the board?
So, the potentiometer. So I'm going to take my red and black wires, and they're going to be the 2 outside, they're going to be in the same rows as the 2 outside pins of my potentiometer. And the yellow wire is going to be the center pin. So they're going to be in the same rows as those pins. So this is going to go to 5V of one of the open analog slots. So open one of the A slots. So 5V, this one's going to go to ground or GND, and then this center one will go to, if you got A0 open, put it on A0.
Are these double females?
So this is male, female.
Okay, sorry.
A0? Yeah.
So that's
I'm at
A7.
A7, yeah.
But you'll just on the code, you'll just have to make sure instead of A0, change it to A7. So you got it resoldered. This is still not. Hey Jeff.
No, really, this is an Arduino. Just
So code uploads. I troubleshooted the code.
Nothing's spinning.
But nothing's spinning. Motor switches on.
Batteries in there, they're not light.
So once you guys get this wired, and I know you're not all there, but I just want to give people that are there some thing to do. If we go and you want to copy and paste the read a sensor piece of code, just read a sensor. That's all we want. Yeah, if this computer will ever. What in the world's going on? So read a sensor. Your robot's not going to do anything. So you're not. It's not going to. I'll show you what's going to happen in a second here. So this is where, remember how I told you that serial.begin and serial.print? So what this is going to do is going to read that value on that sensor, and it's going to print it out on your computer screen. And I'm going to show you how to do that in a second. And the reason we're doing this is so that you guys can calibrate sensors. Because if we just said, turn when this equals to 255.2, we're not going to know what that value is. So what we want to be able to do is be able to see what that sensor value is at a certain point. If it's a line sensor, hey, what is that sensor value when it's touching black versus touching white? And we're going to test that out with a potentiometer. So what I want you to do is upload this code. And then once you get it uploaded, make sure that see this analog number here instead of A0, make sure this matches the pin that your potentiometer is connected to. So if you're connected to A7, change the code so it says A7. Yours might be different than other people. Because you can look at... So this one's connected to A0.
So I think we have our sensors.
So if you have it uploaded, click on the little magnifying glass. Once your code is uploaded, click on this little magnifying glass right here. It's your serial monitor. So done uploading, click on that. You get numbers here. Turn the potentiometer. There you go. So now you can see the different numbers. You know, this can be a light sensor. It could be, it could be this distance sensor. But right now, we're going to use this. So the next step, we're going to use that as our gas pedal.
Oh, okay.
Okay. So you guys get it reading?
We're locked up for a second.
Okay. Yeah.
What is it?
You got this through.
Which sensor are we calibrating?
So no, we're just a potentiometer because what we're gonna end up doing is using the potentiometer as a gas pedal. So we're just doing an analog read. Yep. How are we doing over here? So you getting a value? Okay, making sure.
Things are supposed to change when you turn the potentiometer. It changes when.
So you're reading, so this is connected to A7. What is it on this other side? I can't see.
Oh, this is A4 here.
So then your code, instead of A0, because you're reading your line sensors right now. Are you getting a value? Okay, good. You should be familiar for it, basic Arduino stuff, so you're good to go. Everybody getting a value with a potentiometer? Core A. Done uploading. So now if we go over here, click on this. So now if you turn the potentiometer, see it changes. If we turn to the other direction, so we're actually getting, so that is here. It's connected to A0. So this and the red need to be switched. It's okay. So now if I turn this potentiometer, there you go.
questions from the web about
You good?
What it's supposed to be doing that.
So we're gonna switch your 5 volts and your A0.
To 168 or 192.168 1.1.
There you go.
Here it is. I got it.
Are you guys able to read the potentiometer? Good.
It's just kind of printing out random numbers.
Random numbers.
And then I unplugged everything, and it was still printing out random numbers.
So we're gonna switch these.
It's all HDM. Well, it's written that whole like.
See 5V is in the middle.
It's files
Ground.
embedded in HDM.
And then A0 in the middle. So now you got.
I can give you a folder with, hey, I got a thumb drive with all the code on it right now.
There you go.
Okay.
There. Just a wiring problem. It's okay. Are you getting steady numbers, or is it kind of? So your sensor pin and your 5V need to get changed here.
I know how I did that.
Yeah, I'm gonna double check yours, make sure you're good. I'm gonna turn your power off. Okay.
What is the potentiometer?
So it's variable resistor, basically.
Okay.
So if I have it turned all the way off, it's going to be complete 5 volts. And as I add resistance, that voltage drops.
Gotcha. And is that this?
That's this. So this is the dimmer switch in your house.
Gotcha. And where does that get plugged into?
So that's going to get plugged into here. So each pin gets its own row of legs, its own row of seats. So you turn it. So
Does it matter where you plug it in, how you plug it in?
Nope.
No. So plug it in, buddy. There's no non-polarity on that. All right.
Cool. And then the middle one, so red, is going to go to an A pin. So let's do, for right now, let's do A4. Okay? So the very top one's A4. Let's go over here for now. A4, upper left-hand corner. And then let's do, these go voltage and ground. It doesn't matter which one. Some sensors it does, but with this guy it doesn't. So now when you open up that piece of code, just read a sensor. You're gonna, instead of A0, which is in the code, you're gonna use A4.
Okay.
Okay.
And then how do we get it to do?
Can I take this on right here?
Sure.
Wherever you
stick it right here. In terms of the code, so do you know what the next code to bring up?
Yes.
Okay.
I think it's
Give me 1 second. Is it this code right here?
No.
Okay.
So if you go to the Spark box, right here, click on, slide, close, open, there you go, RedBot. Oh, you hit it, so hit it so it shows. Scroll down, you want read a sensor.
Read a sensor, okay.
There you go. So you're gonna cut and paste this. What you wanna do, you'll see where it says A0, an analog read A0. You wanna change to A4.
Okay.
For him. Cool?
Cool.
No, yeah, I'll come back in a sec. Or raise your hand if you got an issue.
Can I use any analog I want for speed control? And I can just change the program, right?
Yep.
And are we going to put this breadboard up there, or can I just solder it right to the headers like a... I mean, potentially I could just solder this right onto the...
You could, yeah.
That would be kind of cool. And my knobs right there.
Yeah, you could.
What was your game plan?
So we're gonna use, because we want to prototype these bots, and then when you guys get home, that you can kind of modify it a little bit more. But we're gonna go from reading this now to controlling the speed of the motor using that sensor. Gaia? 9600 is the baud rate.
The number wasn't so perfect.
Okay, so what is the maximum number that I get from my potentiometer? Thank you. Can tell you're a student, you answered. What is the minimum value? What is the maximum value I can write to a motor? 255. So we have a problem because we get 1023 from a potentiometer or a sensor, and I only can write 255. So how many? Raise your hand if you got a cell phone, or if you can do math really well in your head. I'm looking at the IT guys. Yeah, what's 1023 divided by 4?
55.
It's like 255 point something. So what we're going to do is we're actually going to take this piece of code, and the next piece of code on SparkBox is, I think it's called gas pedal. So we're going to actually go back here, and we're going to get accelerate with a sensor. And this is going to be just using our sensor, our potentiometer, as a gas pedal. So I'm actually going to copy this. And I'm going to get another new Arduino window, and I'm going to paste it. Remember that we're going to have to change our analog pin number. We're going to have to change that analog pin number to the one you're using on your potentiometer. And then you can use your potentiometer to speed up your motors or slow them down. Cool, huh? So if they're operating in different directions, we flip. So the one that is going backwards, you flip the wires. So you change the polarity of the motor. So if we look at our code, it's 2 lines of code. It's the crazy part. It's only 2 lines of code. I make an integer a variable, and I'm calling it motor speed. And I'm saying, you know what? That motor speed is equal to whatever I'm getting over my potentiometer divided by 4. And then I have the motor drive at that speed. Could that potentiometer be a light sensor? Yeah. Cool. So one thing, because we're going to start populating this pretty well. Keep them on the same row. So like you're using A0, so then move your 5V to the 5V of this one and the ground to the ground of this one. Because then when you're debugging, right, when you got this thing just completely full of sensors, you know which one you're working with.
All right, thank you.
So what you can do is set this as the maximum speed. Right, so if you change that, took that first code of just on, off, and you can use this as a throttle plate, a restrictor plate, and say, you know, I only want it to go 150.
Oh, okay. For the governor.
Yeah, basically.
Now I can just wait until we figure out when to program it to be in like through wireless.
So just so not to let you down, but we're probably not going to get there today.
I know. Unless that's really cool.
But it is really cool. You doing okay? Dude, we smoothed it out now.
Uh-huh.
It's smoothed out now.
I know, that was just like...
Oh, sorry.
We got a bad
You guys doing okay?
Yeah.
I figured you guys like least of my worries right now, so.
All right.
You guys got it working, you got it working. Thumbs up all around. You're good?
Yeah.
Okay.
Is that piece of hardware, is that in the phone?
We're going to give it to you.
Oh, okay.
Yep. Everybody in the back, are we good? Gas pedals?
It's not following lines, but how does it does follow the line?
So, because they're both analog sensors on the pointed down. So when one reads black, one of them will speed up, the one side will speed up. And if the other one reads black, the other one speeds up and slows down. So you get kind of this gradual kind of waddle.
So should we just slow the speed down? Because I noticed it moves really fast.
Yeah, so if you get, these tables aren't the best because they have 90-degree corners.
Yeah. But we couldn't even get it to follow the line that far.
So another thing you might want to do too is do just that analog read and see what that value is, or change. So change this from 255, change it to like 100.
Okay, that's what we were wondering.
Yeah. And then change the other one to negative 100, so it pivots.
Does it have, I mean, it has 255 as well.
Yeah, so you might want to change.
To 100, just make a match and then.
Yeah. So now it'll slow down and be a little bit more responsive. So you could actually incorporate that potentiometer and really tune that speed. So if you just had the motor speed be whatever you have on the potentiometer.
Okay.
So if you want to, so you might want to change so that this one slows down. Or you can swap the motor wiring too.
I took mine down to 50.
There you go. And again, it's manipulation of code, right? Back and forth.
The left side never slows down.
So the other thing too, because these are just about the width of the. Now I made that a little bit wider. So you're not even getting a. So one's 255 still.
I said both of them 250.
Because this one's not speeding up at all. So you might want to double check what pins you're connected to, or. So we have that line follower code. So we have this gas pedal that we can use to control speed. And now if I go snag, so there's two pieces of code that I want to take a look at. So one of them's turn based on a sensor. So one's just going to say, hey, you know what? If this sensor reads black, turn this direction. So that's turn based on a sensor. So if we look at it, and I'm just going to pull it up so we can take a look at it. Most of you are probably going to go straight and upload or go find the line follower code. But we just wanted to make a good progression of this. So I'm actually going to pull this up, and then we'll take a look at it. And then we'll go into line follower. So instead of just motors drive, we now have another function that we have of this motors. And that is right drive and left drive. So we can control these sides independently of one another. So if depending on what I'm getting on this sensor, so if you actually did this with your potentiometer, you could steer this with your potentiometer. So we're going to do analog read. So whatever that value is, if this is really low, this motor is going to come to a slow or stop. and this motor is going to be at 255, so it's going to turn. If this is high, so if it's 255 and this is 255, it's going to go in a straight line. Does that make sense to everybody? So this is turning only one direction based on that sensor. So if I were you, the first thing I would do is upload this code and change the code so it's my potentiometer, and then have speed up and slow down just that one side of the motors so that you can actually turn it. And I know you guys are all having them all on stands, but get it off of the stand and put it down and have this thing turn in a circle, okay? So you can unplug the USB cable. So you might want to make sure that you have changed your code so it's the same pin as your potentiometer.
Okay. So you change your motor right
Wait. Oh, so that it affects from.
Yep.
Oh.
There you go.
Because it's turning. Turn based on.
But now, if you accelerate, that would be like going in a straight line, and then as I turn that down, then it's going to be more of a corner.
So the sensor isn't really doing anything.
You're just using the potentiometer right now.
So we're going at the same speed, right?
Yep.
Is that right?
Yep, and then
Or do
if
we have to
you,
change our code?
so this would be straight line, and then now turn your potentiometer. So that's writing both at the same time.
Yeah, so do we have to do something on our code?
Motor right, left, so A7 divided by 4, it's uploading right now still. Oh, so now done uploading. So now turn your potentiometer. So now this would be spinning in a circle, and as it's sped up, goes straight line.
We should take it on the floor.
My pocket. That's now the size of my phone. Right.
Huh?
should go like that.
Yeah. So this side is
Anybody having any luck? No luck on the line follow?
No, it's just because I don't think this is sensitive enough to see, because it should go like that, straight, and then turn a bit.
Well, mine's gonna hit the wall at the end. The speed it's going.
Do you know that?
50.
I set mine to 40, and I'm pretty sure mine's going faster than yours.
Oh, I didn't change my speed.
Yeah, 255.
That's the next level.
Very nice. Well done. Well done. I don't understand how these are like Is that on high speed? Is it really? Okay, that's what you show me. I don't know. I'm not sure. How do you do
So that motor.drive or motor.left motor speed, right? That motor speed is set at what you're reading on the computer. Okay, so that sets that motor speed.
Oh, okay. So once you find the speed, like there,
What we're doing is trying to build up to adjusting the motor speed for the website.
Do you see what I'm saying?
Yeah, we'll make that connection between sensor like potentiometer and what's happening in the motor speed.
I just make it
Okay, yeah.
I'm like, wow. You know what I mean? Yeah.
I've got. Yeah, well, we still have to upgrade it.
So I think what we have to do is if we're going to slow down our speed, we also have to slow down that.
This sort of works like that divided by anything.
What speed are you running at?
I think it's set for 50. It's like sort of doing it.
Exactly, sir. I'm poking that open.
Let's just see what happens.
How many of you are frustrated with it? You're like, this, right? I am too. So we're going to take a look at it, and I want to make sure that we all kind of understand what's going on. So here's the code. I have A0, I'm using A0 to A1. Your sensors may be different, so you need to make sure you're looking at, and that those sensors, depending on which one's my left and which one's my right, are in the right pins. So if I look at this, motor speed 1 is connected to my left motor. Motor speed 2 is connected to, this doesn't make sense. We're going to change this. So I know I'm going to talk you through this as soon as I get this to where I want to talk about it. So the way this works, those line sensors, they're going to produce something around 500-ish, 600. It depends on where your table is. For example, this one's pretty dark compared to the one in the back of the room. In that this is going to produce, the wider is going to produce a faster speed. Might have it backwards, but you just need to bear with me on that. So white's going to produce a faster speed. Black's going to produce a slower speed, or a lower number. So if I'm my right and left, if they're both on white, they're going to drive in a straight line. If one, so let's say my right touches the black line, which one's going to move faster and which one's going to move slower? My left is going to speed up, and my right's going to slow down, so I'm going to turn, and then as soon as that right one is back on the white, it's going to speed up again, and then this is going to slow down, and so you get kind of this zigzag motion back and forth that's going to follow that line. Here's the thing. If this is 255 and it's full speed, is that going to react quick enough on this, on a 1-inch piece of tape? So you might want to divide it by something more than 4, so that you're working in something between 0 and 100 rather than 0 and 255. Because by the time my robot reads that and says slow down, these aren't stepper motors. They're not just going to stop right away. They're actually going to coast a little bit. So we want to be able to keep it at a slower speed, and so it can go back and forth. Another thing we can do, so I'm going to actually do this with the whiteboard right now. And this is something great to do at home, because I know not all of you have whiteboards at home. So if I flip this so it's a tabletop, I can draw now a broader curve on that to have it follow a line. The way this is set up, this line follower is not going to react that well to a 90-degree corner, which is what these black lines are. If you go to Home Depot, you can get a 4x8 sheet of whiteboard material for like $15. So you can have, one of the cool things that I thought up last night was so the families that have 2 bots, have one robot drive around and draw a line. So put a whiteboard marker on it, and have another one with a line follower, and you can have one, it's follow the leader, right? So play around with it. I'll go find some black dry erase markers somewhere, and you can try it out on a broader curve. But play around with that division speed. So you have this, so you can manipulate your code so it looks like this. Right, this might be A6 or A7. It's up to you. It's customized to your robot. And then I'm going to set those motor speeds based on that left or right sensor.
Sorry, just a second. I'm trying to.
Oh, hi guys. And you might even want, so you might also want to do, so that, just that, read a sensor and bring your laptop over and see what those values look like. What does this look like versus this look like? Trying to figure out if I have the code right. So if this is what, like if this is high, this is low, I need to go that way. So it needs to be opposite.
Opposite?
No, it should be for the same side. So if this is white and this is black, this should speed up, this should slow down.
Okay.
All right?
Okay.
And then if this, yeah. So this is,
Yeah. One of those motors, I don't think you're going to last much longer. Oh, you know what, Mark? Along the line? It's going straight. So that's where we need to I don't know which one works. Yeah, we need to adjust. The program.
got it working? Got it? Do they have the double females? They should have. No, they have male. I think they have male, females. Oh, those. No, because they're getting soldered on the end of this, right? That's what I was gonna say.
So let's go and change our age.
Okay, so we're gonna come around. We're gonna drop off some of these longer double female wires, and I'm gonna tell you what they're for in a second. Sorry, I know it's on keyboard. Yep. Yellow, blue, green, or red, why not? Sure.
That's not working at all.
There's a lot of our products that get worn.
Six is not working for me.
Really?
Yes, I'm pretty sure. One of my sisters.
Yep, you're supposed to only get 2.
Did you reprogram it?
So our red, like if you have our butler that we have, it's RedBot kit, you have 3. So that it's like, if this one's reading, because then that gets into if logic stuff. It's like if this one's black and these 2 are white, it's red, it's that. So just, we try to simplify it too. Especially with this framework class.
Are you sure yours is going straight?
Watch it. If you watch it from the front, you can the left.
So you have to move.
Choose for keyboard?
Oh, you know why? No, I'm not right.
It goes, oh, look, I'm 6 inches away and stop. It's the next one.
Let's just keep trying.
Okay, go ahead, bud.
Yeah, 6 works. I haven't given you guys these yet, have I?
Yeah. It works great. That was the only issue.
here on a tool, but that'd be cool.
Sorry. Yeah, it's standing over the running robot.
Yeah, it's not so we just
We need to.
yeah.
What?
That's surprising, wasn't it?
Yeah, that's
So,
Yeah, quantum stories. That's my first question.
Now I'm going to program the IR sensor so it reacts to distance. And then
what's your number?
That's what we did. Just because it'd be easier for the wires to read.
What'd you do?
Motor. Oops. Gotcha. I voted for it.
Hey, Robert, guess what I just got?
So we were going to use the class set, our class set, but if we wouldn't be able to pull that for you if you purchased it. Because all the back end stuff has to happen before I like it. But yeah, you can do pickup. Is it working, buddy? I don't know where you guys are. Firestone. Yeah. You can do pickup. Yeah, so the XPs are, so Series 1, it's like literally plug and play. Boom, go for it. And then it just replaces your wrong way. So you can send it serial image from your command line. You know, 8 as well as 8.
The left one on the left side and 8.
So that's a, I like them, if anything, just for troubleshooting. So I don't have to like be walking over there with my laptop and it's tethered and it's pulling me with it.
Oh, right on. The all.
So one of the things we're doing with processing.
It's not going at all.
So we're kind of doing. Let's go back. So with robots, what we're working on.
Oh, go ahead. I'm over here.
Started some of the work that we're finishing up this week. Find some basic visual for stuff.
Oh, you're right.
Taking and helping super bright LED.
I lowered the speed so low that it won't move.
Put a camera on the scene. And we can see how that pixels.
So you're right. I have to raise the.
And then, so then I know where the origin is on the floor.
So you know what happened?
Robot knows where it is.
You look at the speed.
That's the brightest point. Brightest pixel. That LED is the brightest point. You're looking at like a dark floor. And so then you can say, 632, 632. Point, and then you can tell the robot with a series of if commands.
Oh, so you try to set it doesn't see. Oh, I see.
And so it will go for it. Depending on how it is.
I got it.
And we're using processing to do all the computer vision heavy lifting on the computer end, and then just sending commands to the robot. Now, there are a lot of computer vision stuff on robotics is solely on the robot. So it's a way of scaffolding kids to have everything on the robot, and now it's...
Keep experimenting, buddy. You're doing the right thing.
Yeah, we'll be getting it. Following? Yeah. Okay, so here, this one's got the wire swap.
Yo, it's what look.
It's following the line. We just had the wire swap.
So it gets black. So
Yeah, well,
but these don't move at all.
we can control speed. We just have to wire it back up.
I know, but
You know what I mean? So you definitely have the right idea, but I think you got to do the other sensors set too. See? You know what I have to do? That doesn't work, remember? That was good. Oh, you're getting it. Try it again. You know what you do? You want to one of them get ordered?
Yeah. Providing by anything higher.
double female wires I handed you. What we're gonna do, because the infrared sensor, so the little eyeballs, wally eyes on the front, it comes with a pigtail, but it doesn't have any pins on it. So what we're gonna have to do with these wires is that we're gonna cut them in half. We're gonna use 1/2 of them, and we're gonna strip them and solder them to that pigtail so that I can connect that then to the board. So if you have a pigtail, can I borrow your guys' pigtail? This one right here. So the pigtail has red, yellow, black. Some of you have red, yellow, black wires, some of you don't. But you're just gonna have to kind of remember in your head which one's which. So the red is 5 volts, black is ground, and yellow is gonna be my signal. It works just the same way that my line follower does or my potentiometer does. So you're gonna cut those wires in half, strip these, strip the other wires, and solder them together.
Could you repeat what they are?
5 volts, ground, signal.
Okay, so red is 5 volts.
So
black
I'm
is
here,
ground.
so this is,
Yep,
red is always
perfect.
55.
Doesn't have to be perfectly in half either. You can use them for something else when you get home or whatever. Yep. Cut them in half. Yep.
Are we heat shrinking these?
I would, yes. And then you'll heat shrink them too. But you can put the heat shrink over the female header.
So you can take them.
What's up? I would use, was it heat shrink question? What was the question?
Oh, do you have any heat shrink? You said we were.
Yes, we can get you some. I'll get you some.
Yes, we are. Thank you, sir.
Green or yellow?
Looks right.
I think we're out of. Oh, never mind.
I was digging out of in there.
I think this is just.
No.
We might want to start cutting the lengths for them because this stuff's too big.
So we like heat shrink. We like heat shrink on these bare wires. Who needs heat shrink? Everybody needs heat shrink.
Around, so everyone should be able to share.
Yeah, so there shouldn't be each
We don't
person
have too
getting
much
one.
left of small stuff. Yeah. You don't need that much, probably we can shrink will do.
I'm just waiting for him to walk up.
Okay. Or just pivot a certain amount of time and change. So if
the red sensor
is equal, is less than or equal to this.
Right, pivot, where we use the function.
So we got an hour and a half.
Get the sensor hooked up and calibrated, get code, they'll have something that's looking for first class.
Is this the way it was? All the time, because like I did the first round of one, and then this advanced round, and I never got to do the second. You know, I would have been doing the second round this year. So it was just constantly in advanced with every kid.
But Mark again saying, okay, I see what you're doing. You realize that.
Anybody got any heat shrink left? Is it okay if I steal some of this?
I mean, it's not one of the extra
Are you yawning?
No, I'm laughing.
I have no idea what I'm doing. So you'll work on me.
I know it like drained half my battery. Joint capacitor, whatever, you know, like something, but it just. Now.
Could you pull up a wide shot of me for a second? Are you on that camera for wide? Can you pull that camera? Okay. Could you guys turn around and say hi to Mara in Vermont? Hi, Mara.
Hi, Mara.
This librarian in America. They're doing like robotics and internet in their libraries in Vermont. So she's tuning in, watching you guys build robots and taking notes.
Getting stuff shattered.
I really like it. Yeah.
Did you see what I saw?
Yes, I said.
Okay.
Left turn's only on this one, right?
So we're gonna aim for maybe getting our soldering and stuff done in the next 5 minutes. Everybody think we can get that done? 5 minutes? Try to. I'm not like gonna, kick you guys out.
I still haven't gotten the solder thingy yet.
This one's
Right? No, well, no, but what we do is we just take this one off and we just run around in a circle. Right?
Special holiday, unreal.
Yep. Hang out with Copper too.
Should I rotate the server side back? You got like this weird where things on what? That would be hard. Okay. Oh. I can hear you can Stop it. On one of these days, Doris. Yeah, I believe we're.
Yeah, no, yeah.
So you guys are now accomplished roboticists, right? You've built the platform, it's rolling, it's reading sensors, and we've added a sensor to this. And what I'm looking for is for you guys to tell me what you think we should do with that sensor.
Great.
Sense things. Can you be more specific? I heard distances. What distance? If we put that sensor on the front of that bot, what distance are we looking for?
The wall.
Oh, excellent. So how do we calibrate that sensor?
Put it close to things.
Okay, so let's, everybody's still soldering, roughly? But I just want you guys kind of thinking out front about where we're going with this, because as this robot approaches a wall, we want to give it some, we look around in the world. We use our senses, right? And what we're involved in here is the epistemology of teaching machines. So we want to teach that machine to start to experience the world the way we do. I'm coming up on a wall. I'm looking around. Well, I'm looking around with my line followers, and I'm looking around with my infrared sensor. So when I get there, the first thing I'm going to do is I'm going to do exactly what we teach young children. Huh? Mike's muted. Oh. Thank you, Mike. Check, check. Okay, so the first thing we're going to do is teach that thing to walk up and stop when it's going to hit something. So we have to calibrate that sensor. Well, we've got some variables in here that are looking at the analog read on pins A1 and A0. And we've created this integer variable called motor speed 1. We've created another one called motor speed 2. Should we create a third one? This is a democracy unless you're going to hurt yourselves or each other.
Yes.
Yes.
We should.
Yes. So I'm going to create a third variable. And I'm going to say int sensor value. And I'm going to camel case this variable, which means that the first letter is small and the second letter is capitalized. And this is a clue for my peer group that down the line, if I open this up, this particular way of spelling a variable keys people in when they're reading code that this is a variable. It's like code that we pass back and forth. So I've camel cased this, and I'm going to say int sensor value equals analog read, and analog read is also camel cased. Analog read is also camel cased on pin, and we've used A1 and A0, so I think I'm going to use pin A2, which is on the sensor bus below the ones we just used. And I'm going to give some space in here, some white space, so that we're looking at this code in blocks. And I'm going to comment a little bit. So I'm going to drop in 2 forward slashes, and anything after this the compiler ignores. This is just notes for humans, right? Comments are good. They're the breadcrumbs I leave behind, so 6 months from now when I open this code, I know what I was doing in the middle of the night. So I'm going to say set value of infrared detector. Infrared distance sensor.
Good. Okay. Yes, sir.
Why aren't you divided by 4?
It's an excellent question. The motor drive functions in the Arduino libraries can take a range of numbers between 0 and 255. I can only pass those numbers. Anything outside of there creates an out-of-bounds condition in the program. It doesn't run right. It gets hitchy. My analog read takes 10 bits, or 0 to 1023. So in order to scale what I'm reading on that sensor to what I can write to the motors, I divide it by 4. So my possible range of values for analog read is 0 to 1023. My possible range of values for writing to the motors is 0 to 255. I divide by 4 to take my highest common value and make it equivalent to my highest common value on the right.
But the sensor can read all 1023.
Yeah, and it has to do with the architecture of how we store that information. I'll come back to that. Yes, sir?
When we're plugging this in, does it go into servo or sensor?
Sensor. This is a sensor. So I'm hoping we may get some servo time here. Maybe, maybe, maybe? Okay. We'll see. So the question would arise, why is one 0 to 255 and why is one 0 to 1023? Does anybody have any idea?
Number of bits. Powers of 2.
Powers of 2. Which powers of 2 are respective to each number? 255 and 1023. You can't answer any more questions. No, so exactly right, though. So we have 8 bits. I have a single bit, a transistor. I can turn that transistor off or on, 0 or 1. If I have 8 of those in a row and I have 2 of them, let's just say I take the first 2, I can have 0 or 1. And then I can have 0 or 1, or a total of 4 possible values, right? 2 times 2 is 4, times 2 is 8. If we keep going out 8 places, 8 transistors, 256 possible values, 0 to 255, square bracket inclusive. 10 bits, right? 0 to 1023 is 1024, 2 to the 10th, square bracket, same thing. So it has to do with how much memory stuff gets allocated on the chip. So the next thing I want, I'm waiting for people to say write more code.
Write more code.
Write more code. Okay. If, okay. I'm going to say if, I'm going to check that condition in the parentheses and I'm going to do what's in the curly brackets. Yes, sir?
Is this pre-written or are you writing?
No, we're writing this. That's while you're watching me type, you should probably be typing as well. So if, I'm going to check what's in the parentheses and I'm going to do what's in the curly brackets. If sensor value so that number is going to be big when the infrared isn't seeing anything. But as I get closer to the wall, what's going to happen? That number is going to shrink. That number is going to shrink, Jeff. That's right. So if my sensor value is less than or equal to, and I use these compound logic statements in my comparators a lot of the time, because if I said if sensor value was equivalent to something and for some reason I skipped that number, I would never get into the if statement. It would always keep passing that because it would never see that specific number. So I write a range of numbers that's inclusive. So I'm going to say if my sensor value is less than or equal to, has anybody got their sensor fired up? We got to figure out what this sensor is going to do, right? So we need a serial print in here. I'm going to say if my sensor value, let's just say, I'm just going to call this, oh, can't do that. What do I do here? Just leave it blank for right now?
Do a serial print for the statement.
Okay, I'm going to comment this stuff out right now. We'll come back to it. And the way I comment stuff out, I make the computer ignore it when it compiles this code. Derek, can you talk about compile?
So what you're looking at right now is human readable, right? We can all make sense of things called motor, write and drive, and analog read. You know, and as soon as we tell you what it means, you guys get it. But if I gave it to you in ones and zeros, you probably wouldn't understand it. Unless you were from the movie The Matrix. In that case, you have a whole set of other problems. So what we want to do is we write code that's human readable, and then when we hit that upload button, there's a program in the back end that we don't see that takes that code that we just wrote and translates that into ones and zeros that the computer can understand. And the breadboard on the RedBot is essentially a computer. And so we turn it into ones and zeros and we ship it to the robot. The robot can understand ones and zeros. The robot can't understand this stuff. So this is a translator for us. It's like Google Translator. So when I hit that upload arrow, it's like me saying, okay, computer, I'm ready, translate this. And it translates it.
Yes, sir.
Did you have a squiggly parentheses before if center?
No, what I did right here is I did /* and that opens a comment. And then I can go as many lines as I want, and then I go */, and that closes the comment. So anything in between /* and */ is commented by paragraph. Anything on a line on a double slash, after a double slash, is commented on a line. So the difference is, right here, I just comment this on this line, but down here we start picking up the code again. But here what I've done is open the comment. Everything here, 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 here is commented, and then I close the commenting right there. And the reason I'm doing this is because I want to put this serial print statement in. This serial print statement is going to tell me what I'm reading on our infrared distance detector. So we want to calibrate that infrared distance detector. We want to start getting some good numbers for that when it gets up on the wall. Somebody got a number for me? You got a number? The ultimate answer. Very nice. Very nice. Yes, you're in the right place. The low number. So I'm looking for something where I'm starting to get reflectance about probably 4 inches away. It should be less as you get closer. Tell me if that's true or not. Load the code, run it, and tell me if that's true. It should be less as you get closer. Yeah, 3/8. Use the 3/8. We gave everybody a bag of 3/8. They should have plenty of 3/8. Okay.
It's bigger, bigger. It gets to about, right here is about 600.
Okay.
Yeah, that's.
And then, okay, so we're going to say if it's greater than or equal to 500. So I misjudged this sensor. It's rather than less than or equal to, it's greater than or equal to. And I'm hearing 600 is a number about 4 inches away.
I haven't done it yet, man.
Oh, sorry about that.
That's okay.
Motor dot pivot.
So it's compiling, and then the cool thing is I can take this ruler.
Okay.
As it's doing it, I can see. What is 6 inches?
So what do I do every time we push that? How do I do that? My takes?
So once it's done uploading, maybe. So hit this serial monitor.
What's
Then you start getting numbers. And if you put your hand out in front of it. Double check here.
4 inches would be our target calibration, and your best kind of approximation of the environment would probably be a white piece of paper.
Black iPad, not good.
But you may end up taking your laptop over to the, yeah.
And I did this kind of blind.
500. Greater than or less? Okay.
Yes, sensor value is E5. Yeah. I'm going to come around the other side of the table.
So I'm going to use the motor.pivot command. Positive numbers turn one way. We can go 100 all the way up to positive 100 and all the way down to negative 100. Positive numbers pivot one way and negative numbers pivot the other way. So I'm going to say if that sensor value is greater than or equal to 500, turn, motor.pivot, right? And what we want to do is we want to start with a left-hand turn. So one of the things, anybody do maze finding? Ever do maze finding before? So what do we know about invariant right or invariant left? So there's a, can you expand on that paradigm?
So if you have to go wall, left, right, you always want to take the same one every time. So say if you want to left, you always take left. If you're in a dead end, you left.
Grab another sensors.
So you always turn the same, as a basic rule without blind alleys and without turnbacks, you can always turn one direction and solve a maze eventually. So we're going to use that paradigm. We're going to take that immediately and we're going to hard code that into our computer code. And if I look at, my my Nautilus maze here, this is my square Nautilus maze. As I come out, and I hit this wall, which way should I turn? Left. So I'm going to turn left and I'm going to come over here, and then which way should I turn? And it just keeps going. So we can solve that. We can solve the square maze the same way, and if we don't start in the cattle guard in the back on the other maze, we just start out in the middle, you can make left turns and solve all these mazes. So we want to take that behavior, and then what we'll do is if you can get through that, we'll add how to do some decision making beyond that, but let's do that first. And that's what we're talking about here. If my sensor value, if I run up against this wall, if my sensor value is greater than or equal to 500, I'm going to turn a certain way. And to tell you the truth, after writing this, I can't remember which way turns which, and I don't know which way you put your pins in. So I'm going to take a guess, and I'm going to say motor pivot, negative 100, and I'm going to delay just a little bit to let it get a good turn. I think I'm going to delay about 100 milliseconds.
They had like their 5 volts between grounds mixed up.
So also, by the way, and just really have to be careful with these sensors. Make sure you get your 5 volts, your red wire to the 5 volts, black wire to ground, yellow wire to your analog pin.
Did we burn one up? We burned one up.
So you got to really make sure that we don't get those pins mixed up.
That's an expensive mistake.
Toast.
Huh? Blue toast? The blue toast?
It only reads out with 5
No, you know what I want to do? I want to cut the ears off it so somebody doesn't, right. So now if I want this code operative, I'm going to take it out of the commenting. And if I want it to turn, if I want this to turn, so I'm going to pivot a certain amount, and then I'm going to wait, and then I'm going to go back into the loop. And as long as this condition isn't met, we're just going to loop through that code at the top. It's only if this condition is met that we go into this turn behavior. Motor.pivot.
Motor.pivot is telling the motor
Turn one way or the other.
and it's going to do that for
So this is like a power rating, but this is my delay. I put a delay on there. Maybe we need to make that number smaller. Maybe we need to make it bigger.
What am I controlling? It's going to pivot, but
It's what you're controlling is the the pulse width that's going to the wheels.
oh, okay.
So if you want to slow pivot, that would be a lower number.
All right, so it's speed.
Speed.
All right.
Thank you. What units are we measuring? Thank you. It is in the libraries already.
I think we got maybe
And I want to hang on just a second.
I was never fully confident if we could follow the line. But who cares?
Motor.pivot. Yep.
I'm sorry. Bye, bye. Can you see? I'm not exactly sure.
Let's try that again. I'm going to it right now.
so-
There we go.
I think I got my rights and my lefts backwards. So let's,
I'm sorry?
So that's the setup. Should have all that already. So the loop right there starts right there.
Okay. So you should, so that's, I started right here and I added int, sensor value equals. So I added this line.
Can I just copy off of this?
Yes. Are we getting turning? Tell me we're getting turning.
Might want to do right motor 255, left motor negative 255.
So it, well, pivot should do that. No?
Or increase the pivot power.
It's only 100 to negative 100. So, okay, good, it stopped. That's awesome. And it stopped in the right place. So now we want it to pivot. Okay. We have new batteries. The other thing is change the order of the batteries.
Yeah, you need to see more of the code.
Yep. Nice.
Yeah. Okay. I didn't know if you just knew by looking at it. No, I'm
longer delay.
Goes off on Gotcha. Okay. I'll just move it down a little bit. All right, thanks a lot.
So you could do a for loop in there. Scroll down. Okay.
See that, Emma?
Derek's got it.
Once you see their stop.
did it so early for a day. That would be my. You're right.
Yeah.
Somebody in the back.
So the wiring for the line followers. So the line followers, you can wire those up to any of the sensors. And that's what everybody has, like, if this is black, this motor speeds up, and if this is black, this motor speeds up. Sorry? Yep, to any of the sensor pins. So it works just like this does, where it has a ground, 5 volts, and panel. Takes 5, right? Tell you what, I know that we have new ones in this.
Are you doing right driving on the
So just toss those.
I bet you it's pivot for a number of milliseconds at current speeds is what I get.
Batteries are getting low. So I got 1, 2, 3, I got 6 left.
Something in the form of shape, but it's not going to work again real quick.
So either way, I mean, I think if we just change the delay speed. Oop.
Okay, I'm going to play it.
I did 400. Clean up my time.
Okay. Same thing. Either way. So, yeah, he'll give it.
Did it work?
Yeah, but I don't know if it's new.
Oh, it did.
Yeah.
So you're getting better play out of it a little bit. So that's why instead of saying pivot, I'm going to try doing motor direct drive 255 and negative 255. So one thing, if we can try, and again, I'm not promising anything, but we're going to try, is that we're going to do, instead of motor pivot, we're going to say motor right drive at 255, and motor left drive negative 255. So I'm going to get full power on the right side going forward and full power going that way. We're going to see if that acts differently than pivot. We'll see. It's the same thing. Same thing as I just physically wrote.
Is that going to go in a circle? Is it speed? high speed, low speed?
Well, the delay will change how long it does that.
Oh, okay, so the delay will be 55.
That's what the delay is. Oh, it is. So if I wanted to.
So pivot can go up to 255 rather than
Go up to 250.
So we just had like half power.
We just have like half power. Pivot can go 0 to 255, and then the delay will control how long it's doing it.
So, but it's the same thing as I have here.
It's the same thing you have, but it's
So that's.
Of course. We're not only operating. It's just constantly. Yep. Wait, let me see. Mine messed up.
How's the jet sound?
Are you still on
That one's up.
Thud.
The difference really changes like 400.
That's exactly what mine does.
Yeah, it's the delay because
those of you who are still on the pivot, rather than 255, that's what your pivot speed to the 255 and change your delay to 200.
So how much?
200. Okay. 255 for pivot and 200 for delay.
Come on, we're gonna upgrade.
You get what I mean, though?
yeah, hold on. I'm turning off the delay.
Always goes way faster than the right.
Look at that.
I don't know why, but my left side always goes a lot faster.
Look at that. Wow. Let's keep going.
I really need to take mine.
So put it in the maze part. So that's why, have it running the line follower until it sees something and then put an if statement.
Right, like that's what I'm doing.
Just slow it down a little bit.
Oh, yeah.
Crazy robots. Oops. Whoa. That's pretty sweet. Oh.
It got to the stopping part. Put it in the just racetrack.
The humor of something just going is well worth the.
So I think what happened.
Nobody remembers the last
See that one that ran that guy over?
The one that blew up.
Awesome! That is killer!
So what's up? Motor was not declared in this scope. So we're gonna go up to the top. So you're gonna need to include. Turn! It's trying. So what you're missing is this part right here. So you're missing this include. So pound include robot, RedBot.h, and then you're missing this part. RedBot motor.
That one worked. That one got fun.
Okay, here's what we do. We have 2 more.
There you
It's persistent at least.
go. All right.
Turn away.
So I think people are still kind of getting grok at
Yeah, see the right side always goes way faster.
So one thing too is put a little bit of a reverse. So like have it stop, right? And then like reverse just a hair. Right?
You just need more speed. Go for go.
Oh, there you go.
Wow.
Woo. A little bit more pivot. A little more. So if sensor value 250, so maybe delay this. We'll try that. Okay. Yep, so you can play with the values. So there's the name of the class.
What did it do?
Class series.
It just stopped? Yeah. Static programming. That was an intentional.
The sensor. That's been a crazy load.
So I'm going to increase the speed.
Here, Sasha.
See, just drop.
Yeah.
So like, go. When it gets to that point, then stop.
Cardboard Arduino. So you do like. Uploading, still uploading. So you gotta make sure you turn this off. The board has to turn the motors on your programming, and then you can turn the motors off. So now try uploading again, it'll upload. I'm ready to just, and I'd be the one to do it. Just be like, and then it completely didn't land on me. There you go. So you made the ultimate cat chaser, so it'll run around and cat. Yeah, there you go.
Okay, go back. Bring it over here.
Thank you.
How many luck? It's Jimmy luck. Hey, you didn't let out the magic smoke.
We're having a umbrella. Let's go in the opposite. Going the opposite.
No, it's just that. Yeah, it's going too slow. So, you know what your drive is.
Oh, wait a minute. Lots of torque.
Can you reach it? Here.
It's just being careful.
Martha, this one's really rough. I'm going to change this one to do it.
It's not, it will not follow line.
See that? It has that bubble.
Run into mine.
It will.
Nice little circle line.
This looks like a tired robot to me.
Yes, and I got some mags on it. And then I do it away. Yeah, this is wondering. Do you know much about XP?
Not a whole lot, no.
All I do is I just type in import.
No, I have. I'm not a robot.
Is that why you're here?
No, I'm here because
What? Gotcha.
So, but unfortunately, I didn't get to do the kit, so do one later tonight or next week. Probably do it while I'm at work.
You can try any combination of these. So I'm gonna put these out. You just throw them away. It'll be helpful. Because otherwise, if they get mixed back in here, then we're just no problem.
Put it in here.
You gotta get your live thing to go.
Not in our bins. There are battery recycling.
I don't think this is going to work. This is too early. See?
Yeah, mine doesn't. Yeah, I don't have the line, so it just like goes straight to like the retarded. Wow, that's great. It's turning and all. That's all that matters to me. Oh my god. I hope you're happy, John. A non-calibrated ruler. Oh man, first mission. Oh my god.
We got working in line. The line side. Hi.
We're the size of 350 size. Adding like, how are you?
Yeah.
They're
Maybe 200. Joey, my robot stops like in the middle of the
Open it. Those are.
Come here. So it stops in the middle of the
Maybe 100 is too high or too low or something.
You can't just, we're just adjusting the speed.
And in the air.
So, is that a high five or a question? Huh? Question, and I have
Where's the other? Oh, there it is. Sorry.
Yeah, I know. I was regretting that. So one thing too, it looks like you have it. See, it starts to the way. That's why the numbers start getting earlier.
Okay, go for it.
Just drive forward.
Back forward. Okay.
What do we have?
Okay, so down there.
So let's turn the motors on and see what happens.
Okay.